Hello, everyone. How was Veka Happy Hour last night / DConf? Everyone had fun? It's these two guys that you probably want to thank for that. So are you ready for a new day of awesome talks? Cool. So here we have Eyal and Shimon, who's going to talk about D at Veka.
Thank you.
So hello, everyone. Yesterday, I gave the talk about all sorts of technical uses of D at Veka. Now, me and Shimon want to present a bit of the different aspects, more of the outcomes that we have, and less focus on the technical D side. So we'll start by introducing ourselves. So I'm Eyal Lotem, and I'm at Veka for 9 years now, so it's been a while. Before Veka, I was at a couple more storage companies. I was at Elastifile. Before that, I was at XIV. So I've seen the storage industry for quite a while. And also, I kind of got a chance to see how things work, like in the world of C, C++, and how things work in the world of D. I think it gave me an interesting perspective. Before XIV, I could tell you, but then I'd have to kill you. And besides that, I'm basically also well-versed in a bunch of other languages, because I'm a big fan of programming language theory. I did a lot of Haskell. I did a lot of open source contributions, a lot of low-level hacking stuff. And without further ado, I'll let Shimon present himself.
Great, thank you. So nice to meet you. I'm Shimon Ben David. I'm the Chief Technology Officer of Veka. I'm in the company for the last 12 years. Can't believe it, but 12 years. Time flies when you're enjoying. Yeah, I'm more than 12. So I'm based in the US. I moved to the US 10 years ago to open a US office. And actually before Veka, also coming from different storage companies, Primary Data, Extreme.io, XIV with Eyal and part of the team here, doing storage environments, distributed storage environments as well. It's funny because as a CTO, I'm supposed to be very technical, but what we're going to do now is going to be a bit of a marketing session around the use cases of where what is Veka doing and where Veka is being implemented and what's the value. But we'll also deep dive into some of the capabilities that it has and what it allows our customers to do. Great.
OK, great. So yesterday in my talk, I mentioned that our customers are some of the most interesting in the world. Shimon, can you give us a taste of that? Like, describe it in a bit more detail.
Yeah, I came prepared. So talking a bit about Veka, you probably heard about us for the last several DConf sessions. So we're already, as I mentioned, 12 and a bit years old. We have 450, around that number always increases, employees. We have more than 300 customers. We raised a lot of money. We get a lot of money. We have a very nice investor list. By the way, if you look at the investor list, a few to NVIDIA is obviously a big one to mention. NVIDIA is an investor in Veka. And also, if you look at Valor, Valor is Valor is the Antonio Gracias fund, the same person that funded SpaceX and Tesla and other companies. So very nice list of investors. So a bit about Veka. What we're doing at Veka, so the product, who knows what does the Veka product do? You're cheating if you're working at Veka. Or sorry, I hope you raise your hand. If not, then take names. Great. So I'll give a brief overview about Veka. Weka is a distributed storage environment. It's a high-performance storage environment that we built, again, we started it 12 and a half years ago. We built for modern workloads, for high-performance workloads. If you're looking at this, and obviously the decision was to build it with D to attain development velocity. If you're looking at the storage industry all those years ago, it was you had high-performance storage, you had NFS storage, block storage, fiber channel storage, but we started seeing, or the founders started seeing also a bit of networking increasing in performance, right? 10 gigabit, 40 gigabit, 100. 100 was emerging, and there was a line of sight for more. We saw flash technology, SSDs and NVMEs were emerging back then, starting to be commoditized. At the beginning, it was a niche market. HDDs were still the main environment. Some storage companies were based on HDDs. We saw SSDs and NVMEs increasing. We also saw the cloud evolution, the hyperscalers, mostly AWS at that time, and the containerized evolution. Kubernetes, Docker was a big thing. Kubernetes started. And then we decided to design a storage environment that is built on these capabilities, because for the first time, it started looking like you can break out of the bounds of a single server data locality. The concept back then was you had multiple servers. They had very thin straws of networking. And when you wanted to get performance, you try to localize the data on the server, HDDs or SSDs, and then you communicated as little as possible with different environments as only what you had to do, so you can get shareability of data, right? But with networking increasing, actually, if you're looking at in the internals of a server into the number of PCI lanes, suddenly the number of PCI lanes with PCI Gen 3, PCI Gen 4 emerging back then, and line of sight to PCI Gen 5 that already emerged, and PCI Gen 6 that will come, suddenly the performance out of the server seems to start to equate to the performance within the server. So we built Weka as a distributed environment where all of the data that we're holding, we're presenting file systems, but all of the data that we're holding is distributed across all of the storage nodes in an equal fashion where there's no data locality. And that's a major shift. Eventually, and we can talk about it for hours. I can deep dive even more. We have a lot of kernel bypass for the networking, for the NVMEs. We have smart distribution. We don't use any hardware accelerator, and that's a big thing. We designed out of doing like a hardware shortcut of a RAID controller, NVRAM, NVDIMM, storage class memory, which allows us to be, I'm going to use a buzzword here, software defined. It was a nice word 12 years ago. Today it's less of a, but truly in the true way of being software defined, because we don't have any hardware requirement aside from a server, CPUs, NVMEs, right, and network. We're really unbounded on the hardware. So as a result, when we started on-prem, on servers, but also on the cloud. From day one, we're running on AWS. Where we see other storage environments where they had to kind of like roll in their servers, their boxes, and say, hey, it's cloud adjacent, it's cloud data, whatever. We're just installing our software everywhere and providing the same value. So that's very unique.
I do want to expand a bit about the kernel bypass. Shimon mentioned the kernel bypass. I'd expand and say that it allowed Weka, and I think it's unique, that from the moment the I/O came in from the kernel, and all the way until it reaches the SSD, it's 100% decode written at Weka. So no kernel, no nothing. Every single bit there is written in D, and it can be optimized by us. And that's part of what allows Weka to be significantly faster than the competition.
Just in terms of outcomes, and we'll talk about specific outcomes, but in general, where we're targeting Weka and where we are showing value, in accelerated use case. So we started with the HPC, large-scale simulations, CFD environments, supercomputing centers, academia research. But honestly, that was in terms, it was great academically and technically, but it was a race to the bottom on the bottom line of the business. So then we looked at the next horizon, which was, again, if you think about it, 12 years ago, was AI, right? AI was emerging, accelerated use cases were emerging, mostly in life sciences and a bit in financials, and some in media and entertainment. And we said, okay, let's go target these use cases, because once you have a GPU, you spend millions of dollars on your GPUs. Again, think about it, 12 years ago, 8 years ago, 6 years ago, before the Gen AI revolution. It was a bit of a niche market, but there were a lot of players that were playing with it. Right? It was, today my daughter talks Gen AI with me, right? 6, 7 years ago, maybe we knew about autonomous cars, right? So we targeted that market, and our claim was, and since then we proved it and we're going to talk about it, was that if you have a GPU that needs to be saturated with data in order to be efficient, to run your training, to run your pre-processing, your pre-training, your post-training, your ingestion, right? If you have a GPU in your environment, you need to make sure that it's fed with data and it's not idle. So that's where Weka comes in. It comes in many places, but that's a very natural place for Weka. As a result, we got very impressive customers. So these are brand names. I'm sure that you're familiar with some or all. So some of them, Core 42 and Nebius, TensorWave are GPU clouds, right? Who's familiar with NeoClouds, GPU clouds? Yeah, great. So GPUs are not easy to host in your data center. They're very expensive. So much in the same way that you have AWS for compute or different PaaS environments, you have cloud providers that are providing specific GPU utilization. So thousands of GPUs running various workloads. Slack, Stanford Linear Accelerator. It's a linear accelerator that really explode particles, does experiment, take images at hundreds of gigabytes per second. Midjourney, contextual, all of these and more. Stability AI are actually foundational model providers. So LLM providers, foundational model providers, doing massive trainings. Right? Think about the OpenAI style, Cohere, Anthropic, all of these. So these are not customers, but the ones that are listed here are customers. Doing large-scale foundational model training, massive amounts of data, massive amounts of GPUs. A normal day there could be with, for example, 700 GPU servers times 8 GPUs per server, right? Increasing in OMRF, Oklahoma Medical Research Foundation, doing genomics research, Genomics England, EBI, right? So there's a nice list of customers. So we have very nice customers. And
can you maybe tell me about the most influential things
customers
that they do?
Thank you for asking. Prepared in advance. So let's deep dive into very specific customer use cases. Honestly, it's bragging rights. We get to brag that these are our customers, but it's also, I think, would be interesting to understand the before and after Weka effect. And again, Weka being based on D, what D allowed us to do. And we'll talk about what D allowed us to do also in these customers, right? So first example, a large autonomous car environment. So autonomous environments, autonomous cars, trucks, drones, planes. We even have robots, right? Physical intelligence environments. But specific environment, in a large autonomous car company in the Bay Area, that we all know, and I specifically. My wife really loves their autonomous driving. What we allow them to do, 12 days to 4 hours. 12 days to 4 hours of a training epoch. Who's running AI workloads here, by the way? Great, great. Okay, okay. In AI, right, you train a model, you ingest data, you change the data, you train the model with your data, and then you run the model out in the wild, in an inference environment or in a component. So 12 days of training the data went down to 4 hours. That's 87 times faster?
Just like Louis mentioned yesterday, iteration time is king, and that's their iteration time. Like doing their data scientists doing this round trip of training, this is what they do to improve their models. So imagine an iteration time of 12 days versus an iteration time of half a day. performance.
And by the way, nobody believes it. 4 hours, it's even less than half a day.
Less than half a day.
But nobody believes that number, by the way. We still put it out there because it's real, and when we connect customers with that specific customers, they'll say it. And we have other customers saying similar numbers in public. But what it allowed them to do, what's the business outcome? So it's great, yeah, we made something fast, but what's the business outcome? It allowed them to actually leapfrog all of the market in terms of autonomous driving. So these guys now have more than an exabyte of data. I was asked to explain what an exabyte is, right? Megabyte, gigabyte, terabyte, petabyte, exabyte, right? By the way, wekabyte is also part of it. Who knows what's the meaning of the word weka? Why are we called weka? Yeah?
It's the prefix for 10 to the 30.
Exactly. Much the same way that Google is 10 to 100, weka is 10 to the 30, plus it's a very cute New Zealand bird, not unlike a kiwi, but New Zealand. So, yeah, sorry, I digressed. So it allowed them to leapfrog the market and come up with their autonomous environments, running exabytes of data on a Weka environment, multiple data centers. Some of their smaller data centers have around 2,000 GPU servers, 1,500 GPU servers. I think some of their larger data centers have around 3,500 GPU servers, again, multiplied by 8 or more for the number of GPUs. That's what it allowed them to do. By the way, they're very demanding. They're running very fast. We always, and I think Ariel can, look at his hair, he became white. They're like, hey, we have a project. We need to go to an exabyte this year. We need to upgrade to this version, to that version. We need this feature or that. And usually they give us a timeline, and then they call and say, we need it in 2 weeks, or we need it by the end of the week. So we need to be very agile and dynamic with them. I'll return the question to you. How does D help us do it?
So they are one of the big users of the upgrade infrastructure that I described yesterday. Their cluster is huge. And because their workload is so huge and uptime is so critical, we are basically using a rock-solid, stable version on their backends. And we only upgrade them when a version is rock-solid, proven itself for a while. And so they needed, in their clients, they needed support for ARM, for different architectures, which we added in recent versions, which we have.
ARM CPUs, right?
Yeah, and we call those versions innovation versions. They are stable, but not as stable as our long-term support versions. So we couldn't afford to upgrade their backends to an innovation version. They're a very critical workload. We need stability much more than we need the new innovation features usually. But their clients did need an innovation feature of supporting the ARM architectures. Now, normally, our clients are older than the backends. It's kind of an input to the upgrade infrastructure is you only need to support upgrades from the front end to the back end and downgrades on the way back, but that's it. You don't need to support the opposite direction. But here we said, what if we try to run the new version, but only on the clients? There it's a reasonable trade-off to run the innovation version on the clients. But this would violate this invariant. So we said, OK, let's just try changing this tiny declarative piece of code that says which upgrades and downgrades exist, and say that front-end to back-end traffic can actually be downgraded, and the opposite way can actually be upgraded. And then the metaprogramming that goes over all the RPCs from these directions and nests recurses into all of the structs basically had to demand all those structs to support the upgrade or downgrade that previously weren't supported. So it gave us a bunch of compilation errors about all the upgrades and downgrades that were not supported. We just added those within a few hours, like a few hours of work adding this. We weren't sure how much work it would be, but a few hours later, we had a front end that could basically work with a cluster that is older. Now, I think this is not something that would be easy to do in a different language. Like if we had used C or C++, there would be no way to basically recursively iterate all of the structs and make sure that they support the data conversion in the opposite direction. And this allowed us to give them the results that they demanded. They are very demanding, as Shimon said, within the time frame.
Very.
And actually before the time frame. And basically, they've been running their ARM clients since on a newer version, which was not part of the original design, but they allowed us to just be flexible and support that.
Yeah, no, fantastic. Next use case? Sorry, before, so again, bragging rights. I'll point it here, so you know it's a very loaded screen, but 6.3 terabytes per second throughput of an environment. I'll point it there as well. 6.3 terabyte per second. So this is taken from one of their live systems, from the telemetry.
They're scaling up the cluster. This number is constantly
And it's
growing.
increasing, yeah. So that show that to a storage person that their system can do these amounts of terabytes per second. Lights go off. Next use case. Who knows the Sphere at Las Vegas? Oh man, you should get out more. Come on. Okay. Huge dome, 16K screens. I'm sure you've seen it, at least in ads or something. It has multiple display environments. It's multiple 16K screen. It's the first full dome on the planet. They're building another one, I think, in Dubai somewhere. U2 came to present there. If you've been in it, it's amazing. It's mesmerizing. Not just the show, but the graphics. So they had a challenge. First of all, they needed to render the show. U2 came and they needed, there's a lot of graphics and animations and videos there. The existing system that they bought, which was a high-performance storage environment, said they started rendering the work, and it was predicted to finish in 3 months. 3 months of a render job, which is, they know that it was okay. That was the expected. But they had a problem. The show was in 2 months. So they're like, math doesn't work. They heard about Weka through one of our partners, Hitachi actually. Brought in Weka, render finished in 2 weeks. So now they had from 2 months, they finished in 2 weeks. Now the thing is, because it's the first time in the world that somebody did such a thing, it was disgusting. It was suddenly they understood that what they did wasn't the pixels, the resolutions was not good. So then they had times to reiterate on it and re-render it and improve it. So then they use Weka for the rendering environment. They're using Weka for the display environment. And again, if you've ever been there, the display streaming from the Weka system directly to the live show. They're taking Bono and the Edge, and they're mixing it. They're amazing. It also allowed them, so that's one business outcome. They could achieve their objective. They could open the show, and every day that thing was closed was obviously millions of dollars. What it also allowed them to do, and I talked with the CTO of Hitachi that was working with them also about it, was apparently every morning Bono and the Edge. I hope you know who Bono and the Edge are, right? Bono and the Edge, after every show, were eating breakfast, watching the previous night show, and they said, hey, let's change this, let's change that. So every day, every show was a bit different. And I went to the show a few times. Hard day at work. and it was different, right? So apparently, the ability to re-render parts of the show in a few hours to a day allowed them to be very dynamic about it. So the business outcome was, hey, first of all, you got your product to market, your show to market, you got to show it, you used it when streaming, plus it allows you the agility of these changes. By the way, the story is that we sold that system not to YouTube, but we sold it to the Sphere. So because the Sphere has multiple guest shows, them, Dead & Co., others, and they liked it so much that they took it to their world tour. So the Sphere had to buy, another system. And also the Sphere, the external of the Sphere, if you've ever seen it, That's also running from a Weka system. The kicker is we have our high performance fashion using our POSIX or GPU direct storage client, the client that Eyal mentioned. This is not running on any of those. This is running on SMB, Windows SMB over Weka, which we support. But we've never seen anybody doing it like that, but using SMB direct and SMB multi-channel to get to decent performance. But interesting use case. Yeah.
What kind of, let's say, value proposition do we bring to our customers? What kind of, beyond performance, what do we bring to our customers?
Brilliant. And I think we'll see it in other customers as well. Don't worry, I have 2 more, and we'll verbalize a few more, so you stay awake. But what we're seeing now, performance is great. Performance is off the charts. It allows you to get to business outcomes. But because we are truly software defined, we don't come to a customer and say, here's our box, here's 3 Wekas, right? We're truly software defined, which is, by the way, it's a double-edged sword, because we can be installed on multiple types of servers, on multiple types of cores, ARM cores, AMD cores, Intel cores, different core counts, different core speeds, different NVMEs, different networks. We're fully agile around it. So it kind of like confused customers. So I'll say what value we confused customers initially. We said, hey, just do whatever you want. And they were like, we don't know what to do. So then we had to narrow it down. We had to say, okay, this is a fixed configuration on that server vendor. This is a fixed configuration on another. This is a fixed configuration on this cloud, on that cloud. And actually that helped because customers are more used to consuming data storage in that way. But the positive of that is that it allows us constantly to run fast with innovation. So literally we certified, we're running on an Intel CPU, an AMD CPU, an ARM CPU comes. I wouldn't say it's a minor change, but it's not that heavy for us to now support it. If there's a new Intel version CPU, Intel CPU version, if there's a new AMD CPU that's coming, we're just tracking the technology and we're supporting it. So because we're truly software defined, and I know Kariel is scratching his head and he's like, oh, you're giving me a lot of headache, but technically we can do it. So when there's value to do it, we can do it. We're not bogged down by legacy hardware that matures in our stocks, right? Additionally, because of the characteristic of the storage, the way we work, the performance that we give, we're actually much more eco-friendly. It's funny because for the last 5 years, I would say we were touting, hey, we're green, we did all of this energy comparison and show that we're saving the planet and like everybody else. But we actually, you know what? I'll mention one thing. Who knows Al Gore? Yay, finally. Some hands, personally, right? So Al Gore has a fund, Generation AM, that actually invested in Weka. And his fund is doing research on technology companies that are promoting sustainability and green technology. And they only invest in these, obviously, and they think that they can make money out of it, right? Which is valid. And they invested in Weka. So we got our green stamp validated. And it was kind of like the coolness stamp. We were buzzword friendly. Lo and behold, a few years later, generative AI, LLMs, suddenly the world is starving for power. You've probably read about it, you've probably seen it. You can't get enough power to these GPU data centers, right? Everybody, like Meta is talking about promoting nuclear plants just so they can power data centers. Heat, cooling, if you look at the cost of power in Europe, more than tripled in the last few years, right? So we have a lot of these GPU cloud partners that are generating green energy, hydro, wind, whatever. So suddenly our ability to say, hey, if you look at our footprint, our power thermal footprint, it's massive. In some cases, we're 10 times less than a similar footprint by our competitors. And once it was kind of like the coolness factor, but now it's like it translates to direct dollars, CapEx and OpEx. I would say one more thing around the technology and what it allows us to do, because we are software defined, and that's what I said, and then maybe we'll move on and I'll explain how we implemented it. Because we are not selling a box that's connected to your regular environment, but we're selling the software, what we're able to do, and we actually started from day one like that, and then we moved to the appliance mode, and then we came back. We're software. We are running containerized. We can limit our resource utilization. Again, D comes in handy. We're installing Weka. We have a mode of installation of Weka that says, let's install Weka on the same servers that you're running your GPU applications on. Why is that interesting? If you look at a GPU server, more often than not, they're around, you have 128 or more CPU cores, you have a terabyte or more of memory, you have NVMEs, you have networking, you have massive amount of networking between GPU to GPU communication, 8 400 gigabit NICs usually, and it's going to increase between GPUs, just for the GPU to GPU communication. When we're installing Weka on these same GPU servers, out of 128 cores, let's say that we're taking 8 or 18. Out of the 1 terabyte memory, we're taking 32 or a bit more. And we'll take the local NVMEs of the GPU servers that are just there for scratch, and we'll accelerate all of that. So by taking this predictable, deterministic amount and never asking for more resources from the server and installing ourselves on the compute servers, on the GPU servers, we're creating the Weka environment. Just to give you like an example of the value, imagine that a GPU server that's talking with its own local inbox NVMEs without Weka is getting from an NVMe, usually you do a GPU to an NVMe pairing, is getting around, depending if it's a PCI 4 or PCI 5 NVMe, 7 to 12 gigabyte per second. On a Weka environment, if that same GPU server is running a Weka converged environment, it can get to 80 gigabyte per second. Single server, single mapper. So now the GPUs can get the data at 80 gigabyte per second. More than that, because we patented a protocol that's called GPU direct storage, where we are bypassing the PCI switches, the CPUs, the memory bounce buffer, the NUMA regions, and the GPUs are just communicating through their local network, closest network ports, directly with the storage and getting the data back directly to the GPU's high bandwidth memory. We're measuring a single server getting GPU performance of around 330 gigabytes per second, or 2 million IOs. Yesterday, my team did a demo for a customer in Singapore. They were running a benchmark that they're running with our competitors as well. And they asked us to run the benchmark like 5 times. They didn't believe it. and that's something that we're seeing all the time. Nobody believes it. These are insane numbers. And again, what does these numbers allow our customers to do? They allows them to leapfrog their competition. And we'll talk a few more examples.
About those insane numbers, I was talking to one of our sales guys, and he said that before Weka became famous for its performance, if they actually told the real numbers to customers, they'd get thrown out. You're lying. They're like, it's not interesting. They would have to lie to make the numbers worse, just so they don't get thrown out.
It sounds funny, but it really happened. I remember we had a new sales guy, our first sales guy that came, Matt Burley, right, amazing. I would go to customers with him, and he would say, we're 6 times faster than the competitor. And then after the meeting, I was like, what do you mean 6? We're 60. And he's like, Shimon, if I tell 60, we'll be thrown out. So yeah, but now we have customers saying that, which is amazing. Memorial Sloan Kettering, cancer research in the US, are publicly, there's a video of them saying, with Weka, they were using a high-performance parallel file system, best of breed or whatever. I won't mention names unless you'll corner me. Please corner me afterwards. With Weka, they're saying we're doing 30 times more science. 30. Literally, they're doing 30 times more cancer research. The fun thing is that they're saying their PhDs are finishing their PhD faster because they're doing the proposals, the verification, their experiments runs faster.
Iteration time is king.
30 times. So we ran on Microsoft Research, Bing, which are a customer, obviously, and they were running their workload on a Weka environment, and then they were running the workload on the same environment that's just running a different parallel file system, and Weka was 40 times faster. And they're like, no, you're cheating. And we're like, it's your workload, you do it, it's not even us. So now these numbers are, it's funny to see after 12 years that suddenly it's believable. Another use case, stability AI, stable diffusion. Who's familiar with stable diffusion? Wow, that's great. So stability AI are running on Weka. Before and after Weka, they were running their model training on AWS, connected to the best-of-breed high-performance file system on AWS. It's called FSx Lustre. It's a variation of Lustre, which is a parallel file system from the HPC days. They moved to Weka running in, as I mentioned, running in converge mode, where Weka is running on the GPU servers. So around 680 GPU servers running Weka instead of being connected to our remote file system. They dropped their price by 80%. They increased their performance 15 times. And there's also something that we don't talk about a lot, but there's simplicity of operations. Once you have one storage system to rule them all, because we're high throughput, low latency, high IOPS, and high metadata. When you look at file system performance, these are the 4 measurements. And usually you can get 1 or 2. You can get a file system that's high throughput, or high IOPS, or high metadata. And then you have to kind of like try to move your workload accordingly. You have to say, okay, maybe I'm doing a throughput workload, I'll do it here, or an IOPS workload, I'll do it there. Maybe I'm doing an S3 workload, right? S3 is a protocol even. I'll do it on an S3 bucket, but then when I need high performance, low latency, I'll copy it. So these storage environments are usually very complicated. Multiple storage environments for multiple protocols, multiple pricing. And then with Weka, we just converge everything. We're just saying, hey, run all of your protocols on us because we can support them. And we're faster than your local NVMEs in all aspects. So why would you copy data back and forth? So stability AI, huge use case. Was there something that we wanted to talk about stability AI that actually allowed us to accelerate them?
It was a different customer, but I will interject the story. It's basically Weka has this feature where you can utilize Weka as kind of an SSD cache in front of object storage, allowing us to also give you for most of your storage, you get the cost of object storage and spindles, but for your actual accesses of data, you're getting the performance of SSD. However, that customer had accidentally deleted all of one bucket's S3 bucket's data. And suddenly, they didn't even notice. Like a couple days later, they were starting to get 404 errors from the S3 when trying to access some Weka files. And they're like, guys, what's going on? We're not accessing our data. And so we told them what happened. And luckily, they had S3 versioning enabled. So basically, all of the data was still there, but you couldn't just get the objects. You had to do something like list the versions of each object and then find the version and get. And there was no simple like restore from old version or anything like that. So they asked Weka, can you help us like get the data? And I think it was a couple of years ago, but I think in just, less than 48 hours, we could basically add this feature of whenever you get a 404, try to query the versions, get the latest one, download that instead, make sure the integrity is all correct, make sure everything is fine. And we could deliver them this feature within, I don't remember if it was 24 or 48 hours. It was a few years ago. And for them, it was like, it blew their mind that we could like give them this feature so fast and they could just access their data again. And I personally believe that D is playing a big part in that, because like developing a complex feature like that into a real-time storage product, I don't think I could have done that in previous companies in that time frame when we were using C or C++ or anything like that. So I think in that sense, our customers also enjoy the benefits of D indirectly. I think in some cases, very much so.
Brilliant. I won't belabor the point, but Nebius, if you're familiar with Nebius, CoreWeave, and there's a bunch of others of these GPU clouds, they're running Weka. The one thing that they enjoy from is the ability to run different unpredictable workloads. Because if you look at that GPU cloud provider, it's everything. It's training, it's inferencing, it's many things. So the ability to say, hey, whatever you throw on us, the storage will handle it, is very unique. Sometimes we don't even appreciate it. You know when we appreciate it? When we see our competitors exploding there. Just for the sake of time, challenges. It's not all hunky-dory, obviously. Want to cover a few challenges that you think D has?
Yeah, we touched on it yesterday. Somebody asked about our release build time, like the production build time. It used to be like 50 minutes, and it grew to like 90 minutes or so for the production build. Now, it has to do with the fact it's cutting edge performance. Like if we were using a language like Go, I'm sure our compile times would be great, much better than that. But of course, the price of that is that you get a language and a compiler that doesn't do much for you, and you don't get the performance that our customers expect. But also, on the other hand, we don't think that it should take that long to build our product. Like I'm sure that there are many things we could change to make it better. But here it's kind of a call to action. We really would love, maybe for the community, to help in identifying ways to find the causes of these enormous compile times. We do know that our generated code is huge. It's huge. It's not easy to figure out what makes it huge. Like what's in our code, what's in our templates, which one is responsible for how much. So that's something that could really help us. We did get a lot of mileage from the trace time feature that was added to the compiler. It really helped us in our iteration time. Local builds became much faster. But the release build is still heavy because that requires the visibility into templates. So there are a lot of, I would say, nobody uses a programming language and doesn't hit like these cases where he says, this is suboptimal. It would be nice. But overall, I think D reached a place where we're very happy with the language and its capabilities. And so I would say this is like the major thing that could really help us.
Yeah, please help. And yeah, we have a minute remaining, so thank you and questions, and please feel free to scan the QR code. And yes.
I want to say I'm extremely pleased that you guys are making lots and lots of money off of using D. To me, that kind of validates our whole purpose of being. Is we love it when people use D and make money, especially lots of money with it. So.
And progress humanity.
And the other part is I'm really proud of the D community for creating a product that works for you guys and makes you guys money. So I'm happy for all that. And when are you going to have your IPO?
Next question.
Is it easy to integrate in another system? Can you actually, if you just use a normal file system, can you use it? Or do you have a sandbox for testing?
I'm not sure. I'm not sure I got the question.
Is it easy to integrate if you are running in development in another?
How can you
Okay.
test Weka or?
Yeah, do you have a sandbox or do you have a mini version where you can test the API?
It's very easy to spin up a Weka environment on a cloud
Okay.
using CloudFormation or Terraform. Minutes
Do we have the API? Is that public?
to do it. To
Yeah,
spin
the
up a Weka
API for it, is that public? So do we have a?
I think we made the Terraforms public. I think.
No, I mean if I want to write code to it.
No.
Yeah, so I can't send a remote procedure call to your system. I don't.
Oh, you do
API.
have, if you want to use Weka's API, you mean use a bunch of APIs, like instead of a CLI, for example, to do change?
Yeah, exactly.
Oh, yeah. So we do actually have two APIs. Like the official API, we have a REST API. And also underneath that, we have a gRPC API. Kind of like evolved with the times. Back in 2014, gRPC was the hot thing, and we made a gRPC API. And a bunch of years later, REST became the hot thing, and we made the REST API, but you can access the system.
And that's to integrate with it. Usually we see customers doing it for monitoring environments to query the system and push the data into there.
I'm thinking if you just have a standard database, can I just access it like a file system?
So if you have we have customers running databases on Weka, so the database is using Weka as if it would have been their own local NVMEs. Right, depending on the database, imagine a time series database, Cassandra distributed database, a document store, even data lakes environment. Usually the local lore is they're using high performance local NVMEs and they're replicating the data between them because shared storage is just usually not enough. But with the concept of Weka being faster than your local NVMEs, so now these databases, we have customers running them at scale where these databases are just using Weka mount points. And these mount points are, as I mentioned, faster than the local NVMEs. So they're actually, that's the way they're using it. There's also a way to, we're coming up with a data catalog where the data on Weka can be queried for its metadata. Maybe that's some of the question also. Instead of mounting a file system and say, show me how many billions of files there are and find.mtime and run a query against a Weka data catalog that will tell you these are the files that changed in over this time period, or these are the attributes that change, or depending on what you need to do.
Thank you.
Thank you. There's another. Oh.
How can I try it?
So it's really easy to spin a Weka on a cloud environment. Terraform, CloudFormation, we're running on all major clouds, AWS, GCP, Oracle, Azure. Plus, if you have an on-prem environment, our minimum environment is 8 servers. Yeah, but we're not designed for your laptop, right? On purpose. Yeah, contact us if any of this is applicable and interesting.
I had a question on your data flow. When things are coming in from the net, is there any kind of hardware assist at all, like for any kind of checksumming or anything that's common on your hardware devices? The other thing I was questioning was, what is your compilation environment? I mean, you have like a bunch of CPUs running, or is it all mono-thread, or what's the story with the 90-minute thing? And yeah, I just wanted to know those two things.
So I'll touch lightly on the first thing and then the compilation. So the hardware assist, as I mentioned, we don't like to offload anything to the hardware because that usually ties you into a hardware environment. So for example, there's a NVIDIA came out with, or Mellanox came out with these Bluefield DPUs, where you have the NICs and then you have cores on them, and they're trying to force the market to use all of them, which they do have some utilization and use cases, and Weka does integrate with them, but for specific users that want it. However, I think you just touched a good thing. We are offloading on Weka. Everything under the hood is 4 kilobyte pieces, and every 4 kilobyte are checksummed for validation, because with data, when data goes across the wires, there's bit flips, there's bad cables, and we've seen all of the above: bad cables, bad NVMEs. So we do save the checksum of every 4K that's along with the 4K itself in a different location for maximum protection in runtime. And these 4Ks are actually calculated by the NICs, but because it's a standard operation that the NICs are doing anyway, we're actually offloading it with the DPDK stack. So it's a hardware assist that's available everywhere, including the cloud environments. But that's almost the only thing. We don't use any other hardware assist.
And our compilation environment, we compile on the cloud, and as I said, we have 3 build modes that we use. We have the debug build, which takes, I don't know, it could be between 3 and 8 minutes or so. It's not a disaster. It could be improved. And we also have the release build that is still packaged, so you get multi-threading. You have a bunch of threads building the different packages separately, independently, in parallel. And that takes, I think, 30 minutes, maybe 40 minutes. And we have what we call the by-exe build, where you give the compiler all of the D files in one go. And the reason we have that is we observe that there is a slight performance improvement when you compile that way. And it doesn't make sense to build that way in your day-to-day work, because it's only a slight improvement. And instead of taking 30, 40 minutes, it's taking 70 to 90 minutes. So it doesn't make sense for day-to-day, but even a slight improvement is worth it for the production build, because you do it once per general availability version that you release. So the 70 to 90 minutes is not that important to us to shorten. Again, it's for the final releases. But the 5 to 8 minutes debug builds and the 30-minute release builds that aren't by exe and they are threaded, those could really help us if we could shorten them.
Does that answer the question?
These compilations multi-core, or the shorter ones you're talking about, do you get multiple CPUs involved, or is it a...
Yeah, it's a parallel build. It's a standard parallel build, yeah.
Okay, and but the 90-minute one is a monocore, or is it multi-core as well?
I'm not sure if when you tell LDC, please compile this 2,000 D files together, and then it feeds all of that generated AST codegen code into LLVM. I'm not sure whether internally it uses a lot of multi-core or not, but in theory, it's just a single command. So I won't be surprised if it's not very parallel.
Unfortunately, we don't have time for any more questions. But before we wrap, I want to apologize for those of you who are watching the live stream. Unfortunately, it's just me now, and I wasn't watching on questions on the live stream, but we'll fix that for the next talk. So thank you, Eyal and Shimon.
Thank you. I want to take a selfie with all of us. Come. We'll take 2 selfies. 1, 2. Thank you.
So this year we're gonna have a premiere. Like it's gonna be like the first in-person conference where we have like a virtual talk. Adam was planning to come here, but when he landed on Heathrow, he found out about the personal emergency, so he had to go back. But he wanted to give this talk. So everyone, please, a round of applause from Adam for Adam.
Hello, everyone. All right. So this year, I would like to talk about Phobos 3, which we talked about last year. So what have we been doing? We've been working on something. But first, this is a picture that my dad took about 3 weeks ago at Oshkosh of an airplane named Aluminum Overcast. And this airplane actually represents a little bit of what's happening with Phobos 2 right now, because this is still an airplane and it flies, but it has cracks in the main wing spar. That means that someday, if they were flying it, the wing would fold up and the plane would crash. So there's a little bit of that, like we have, and I discussed this extensively with Phobos 2 last year. We have some problems with Phobos today, auto decoding for one. So Phobos 3, we're going to try and fix all that. But sorry, this is the picture. I just realized I was on the wrong screen. That's the picture. And so where are we today? Well, today, there's 4 modules. Now, I know that doesn't sound like a lot, but meta is mostly done. And traits, this one, I don't know. You guys probably heard a lot from Jonathan. The original plan was he was going to be after me and I didn't have to like summarize it, and I wasn't able to watch the talk yesterday. So you guys will have a better idea of what it is now. What I do want to say, though, is you can actually use these. And personally, I would like if you would. There's some new traits in there. I'm sure Jonathan talked about them. There's some rewritten ones. We're going to talk a little bit about that later today. But this is obviously an under development library, so the symbols may change. They're currently today, Jonathan is also working on ranges. He probably talked about that a lot yesterday. And there have been various people working on a replacement for the nullable type in std.typecons. Paul Backus has offered to work on one. I've looked at working on it. One of the things that everyone agrees that it needs to do is drop support for ranges, and that's actually pretty easy to do, but it's a major breaking change, so we don't want to do that to Phobos 2. And it's a great example of the kind of thing that we're looking to do with Phobos 3. We've had some challenges that have proven either difficult to work around, or we just kind of have to say, this is how we're going to handle it. And unit tests has been a large one, because unit tests will routinely call into other modules in almost like a circular dependency fashion. And we don't have those modules available yet in Phobos 3. So we've kind of had to say, okay, write your unit tests, use Phobos 2 inside the unit test, and then we can come back later and fix it. Neither of the 2 modules being worked on today are merged into the main repo yet, so unfortunately you can't use them. And as far as the nullable type and rebindable and stuff like that, We are exploring various ways to flatten out type cons specifically. We don't know exactly how all that's going to work out yet, but everyone has agreed so far that we want to do an optional module. So this is the rough order that we think that we're going to be able to do things once we get ranges. Ranges are holding up everything, and because they're used everywhere. And this is okay. We need to get ranges right because they're used everywhere. The biggest user of them, of course, is std.algorithm. The one thing that most people that I've talked to seem to agree on is that we don't really need any major like new algorithms. We don't really even need to redesign the ones we have. We really like what we have. But one of the things that we have run into is the names are confusing to people. So, for example, count until is commonly referred to as index of. I talked about this quite a bit last year. We're going to do some renaming and reorganizing there. Obviously, all of the string handling modules are going to have to redesign so that we can remove auto decoding. That all makes sense. stdio is going to be split apart, and we're actually going to create an entire new trunk branch or trunk mop package. And that one will be console. We want to leave as close to as you guys are using as possible, with taking into account some of the things that need to be updated, like IES, and there will be some name changes in there. But file IO is where things get really wild. We've talked about replacing we have this kind of thin wrapper over the C file struct that we don't want to keep in Phobos, and so we've actually talked about replacing it with IO pipe. And if you guys haven't taken a look at it, Stephen Schweighofer, I hope I'm saying your name right, Stephen. This is the link down there to that module, and he's been maintaining it. So, talked about the holdup, got ahead of myself there a little bit. It is just Jonathan working on it, and it is just in his spare time. So if everyone could please give him a handshake or, a thank you, that would be most appreciated. He has been doing phenomenal work. So one of the things that Jonathan and I spend more time than anything else talking about is naming things. And if you guys remember my talk from last year, we kind of talked about the philosophy that we were going to use about naming. Now we have some actual examples. And this is one of them. This came up about 3 months ago. And it is type of symbol and type of expression. Okay. And what happened is the similar prefixes, the type of, actually made it fairly difficult to distinguish in the code what the difference was. And you can see down here at the bottom, I've kind of highlighted that the prefix itself was longer than the actual name. And so that made it kind of difficult to read. Jonathan actually reached out to me and said, I don't like these. Can we do better? And so this is what we came up next. We took type of, dropped the of, put type on the end. Okay. Postfixes, generally a little easier to read, but they were still kind of confusing at a glance. There's still only one character difference, in length. And Exper is not really an abbreviation that people are going to be familiar with, which, as we mentioned last year, was kind of something we wanted to avoid. Okay, so this is what we came up after racking our brains for, I think, 2 or 3 days. We didn't like this either because symbol type is fine. but expression type is horribly long to type out. But they meet the other rules of what we were trying to achieve. And so one of us, I don't remember who, asked a different question. And what we actually came up with is property type. Because sometimes when you're naming something, you need to step back and ask the question, not what is this thing, but what is it used for? What is it doing? And I asked Jonathan that, and he said, oh, it's used to get the return type of a property getter method. Oh, so we're getting a property type. And that's how we came up with this. So one of the things that we learned is that abbreviations are just hard to read when they're kind of mashed in with other code. And abbreviations are also actually arbitrary to the language they come from. And by language, I'm not speaking D, I'm speaking English here. And this was actually a key point that came up, and we wanted to try and keep like a sim type, because that would match with expression type really well, but it is visually way too close to some type. And I mean, they're literally different by one character, and the character itself looks similar to each other. So I am I do user interface design as part of my job, and I have taken a few classes on it. One of the things that I still remember to this day from that class 14 years ago is this taxonomy of human visual data processing. That's just how do humans take in information. And first we see color. Color is why syntax highlighting is so common in all of your editors. Vim has it all the way up to heavyweight Visual Studio. Everyone wants syntax highlighting, and this is why. Shape is another way. So you will see a green square, and you will see it in that order. This is also why indentation is so frequently fought over. Is it 2 spaces? Is it 5 spaces? Is it tabs that you can set the number of spaces on, et cetera? And it's all because of the shape of that we are interpreting matters. And text is, of course, the most difficult thing for humans to read, because we actually have to sit there and process out the text as an image, as a picture. When you think about reading, you don't actually read the individual glyphs of a word. You interpret the word as if it were a picture itself. This is, interestingly enough, why logographic languages like Japanese are just as legible to humans as alphabetic languages like English. And what this meant for us in the prior example we were talking about is that the variety of word shapes reduces cognitive load on the programmer. And part of the reason that we are so worried about this with Phobos 3 is in a normal program, you'll write out a function and you'll call stuff, and you'll write it out once, and you'll read it maybe 100 times. But when we're talking about a standard library, you'll type it out once, but you'll read it 1,000 times because we use it everywhere. So abbreviations violate word shape, because your brain takes that space and it kind of deletes it. But if there's an abbreviation there, your brain has to stop and say, oh, what was this half of a picture intended to actually be? And so you have to sit there and process and cogitate. So I have this view that APIs are the programmer's interface to the machine. And that because of that, we can infer that the same rules of user interface design apply to API design. And short characters reduce the number of characters in the namespace, which reduces the number of possible visual shapes in the API, which makes things harder to distinguish and can actually cause the visual collisions such as sim type versus sum type. And I have the types, typefaces here in a fixed width font to make it easier. But if I was to put these in a standard font, you know, like Arial or something, they get a lot less distinguishable. So these are the brain hacks to think about as you're designing your program, your API for your library. What we have talked many hours on Discord, primarily. By the way, guys, most of Phobos is happening on Discord. Because we are in this high creativity phase of Phobos right now, where we're trying to get all of these ideas and what's best, and oh, that's not going to work for this reason. And Discord has worked better for everyone involved in it. And because of that, most of the conversations about what capabilities Phobos is going to have in it have been taking place there and not on the news group. Here's some things that we have come up with that we need to have in Phobos 3. Data formats. This actually came up on the Friday of the conference last year. Matthias brought it up and said, "Yeah, can we get data formats in here?" And I said, "Yeah, I'd love to." But it's a lot of work, especially since we don't have ranges. So my view is JSON and SDL are mandatory because having those in Phobos will greatly simplify a dub development, but also tool chain in development in general. I would like to get XML in there if I can, but we need a compliant implementation. Now, Jonathan is going to immediately put up his hand and say, but how compliant does it have to be? And we've had this conversation, and there are things in XML standards you probably should not implement for security reasons. I would say those should not be in there. YAML, we have kind of the other problem. YAML is huge with a spec that runs on for novel length. And getting an actually compliant implementation into Phobos is going to be quite the chore. I understand people are going to say, "Oh, but I can implement this small piece of it." But when we're dealing with standard libraries, we have to think about we're saying, "Oh, we offer YAML," and someone's going to go, "But I use the Norway problem, right? I know how to use it and deal with it," and we have to support that. Another one that came up, I was just chatting idly on Discord one night, and somebody said, "Oh, what about why not just use the SHA algorithms in std.digest?" And I went, wait a minute. Please tell me those are calling out to the operating system libraries. Oh, no. We wrote our own in D. I have bad news. They are pretty much guaranteed to be insecure. Writing actual cryptographic algorithms is probably one of the most complicated things one will ever do with their lives, because there are these weird interplays between the language, the machine, and the libraries that you're using, and all these just minute details can blow apart an algorithm, and somebody can crack it. So we cannot ship those for just straight up security reasons. What I would say is that we need cryptography for security. We need to support the intersection of what is supported on the major platforms. So that would be Windows, Linux, Mac OS, and its derivatives. FreeBSD, of course, could be supported. After that, it's kind of like we'll probably have to polyfill it with OpenSSL or something like that. But never, ever, ever implement your own algorithms, ever. The other thing that's come up a lot recently is that everything is on the web, literally. And we don't have an HTTP client. I understand that there are packages out there that do it, but you have to decide which package you want to use. Do you want to use Vibe? Well, you've got to use a lot of other components of Vibe, and that's fine. Kind of a heavyweight solution. There's another package that I like using called requests. That's based on the Python requests, and it's a great library, but it very much follows sort of the Python model and not the D model of working with data. We should support HTTP 1.1 at a minimum, and if possible 2 or 3, but I will not make that a requirement for Phobos 3. So, and I want to reiterate this because I can hear Walter in the background already, because we've talked about this. Is Phobos 3 is primarily about what we already have, cleaning up things like auto decoding, and getting into the naming and the oh well, we actually need to rethink how ranges work for this reason and that reason. That is our focus, but data formats support the tooling ecosystem, which will help us grow D. Basic cryptography is necessary for security, and the world is web-based. We have to have that. I don't see any way we can go to people out there and say, oh yeah, D is this great language. Oh, by the way, we don't have an HTTP client you can use out of the box. Pick one of these, five out there. There are some capabilities that will be removed. std.json, everyone kind of agrees, is junk. So I've actually been working with a Google Summer of Code student this year, and he is working on a JSON IO pipe, which is based on Stephen's IO pipe. And the idea being that we can actually use JSON IO pipe as a example of how to implement like an XML or a streaming, deserialized, serialized interface on top of the IO pipe features that we would like to get into Phobos 3. And so we will take out std.json and we will, there's a typo there. It should say phobos.data.json instead of std.json there. Get opt. I've received a lot of requests to remove and rethink. And if we can't rethink it, just remove it. I mentioned the digest algorithms. Anything that's considered a cryptographic hash algorithm, we have to remove, even if they are old and broken, especially if they're broken, actually. st.experimental is mostly just allocators, and nobody can agree what to do with allocators. And it is labeled experimental, so we don't have to keep it. And std.logger, this one I don't really want to remove it. I would like to see it rethought if we could. Most logging systems in a standard library will provide like a standard interface, and then you can hook up whatever log you want underneath it. But we'll see what we can do there. This list is subject to change. People have been, talking to me. Oh, what if we could do this and get rid of that? And it's like, the one thing I will say is that the more removed, the faster Phobos 3 comes. So, there's that advantage there. Another thing that we have dealt with that has been very difficult has been attributes. And this one has really caused us some heartburn. So first I want to kind of talk about the philosophy of attributes. Talking on Discord, people say, oh, you put no GC, no throw on a function, and you're writing in a different language. I've seen people say, oh, well, it's not really D. I argue that that's not correct. They are different programming philosophies. The no GC, no throw philosophy is maximum performance, maximum control. The other philosophy is Walter's safety philosophy. He wants, can we do safe by default? But you're going to give up speed for that. You're going to give up, a control over the code for that. But you will get simplicity. And neither philosophy is incorrect, but they don't really interact well. So, and Phobos 2 is a mixed philosophy library. And I'm going to show you an example of what that looks like here in a second. This is the list of the attributes that are troublesome. There are attributes that are not troublesome, as like app property and whatnot, but these are the ones that are causing everybody heartburn. And the reason they're causing everybody heartburn is because attributes represent limitations on the implementation, but they also represent promises to the caller. And because they represent a promise to the caller, removing attributes is always a breaking change. And it's not just a breaking change in like we can kind of work around it. It is a breaking change for every possible caller above you the moment you ship it. And since we're the standard library, that's everybody. So the actual rule in Phobos 2 right now is thou shalt never remove an attribute. Just, you can't do it. In most cases, we can add attributes, but aggressive attribution prevents us future changes. Like we can't say, oh, well, this algorithm was no GC, but we came up with this cool way of doing it, and now we're using the GC. And everyone's saying, oh, the GC is slow. Why would you ever do that? Well, there's a new GC coming that's not slow. A method that has been attributed as no GC or no throw can never be changed in the future ever again. It's frozen that way. So can we do that with existing code? Because yes, a GC function can call a no GC function, but a no GC function that calls a no GC function and that gets changed to GC and it blows up. And then the person who wrote it is now angry at us. So this is an example of a PR that I actually merged in October of last year. The link will be on the next slide. And what you're looking at is pretty much the whole pull request. You can see the new on the red, and it's replaced by this call to pure malloc. And then if you look down here, the unit tester switched to no GC. This is the current signature of that method today. If you were to go look at the Phobos files today, this is what you would see. And there's the link to the pull request. So did you spot the fib? It's not an outright lie, but we're kind of shading the truth a little bit here. Because the method itself doesn't actually specify no GC, so you can't tell from the documentation anywhere that this method is actually callable from a no GC method. And there's actually another bit of a fib in here, and that is the method is technically no GC, but it actually does still allocate. And this has been a problem because people come in and they have this vision of no GC as one of two things. You have the people who've been around a while and they understand that no GC literally means no calling new. And then you have other people who think no GC means no allocations of any kind ever, because they're looking for the performance aspect. And so they're not suspecting that you're going out to the GC. I explained that what happened with this PR to Walter, and he actually told me straight up that I should no longer accept PRs that look like this. There's a lot of problems with that PR that make it not acceptable to do things that way. You'll note I'm not naming names, but this PR does come from a prolific contributor to D. The other rule change that we're going to make is that, if possible, we need you to be explicitly stating your attributes. It's partly for documentation reasons, but also if somebody were to go remove that no GC from the unit test, we can go straight back to no GC or to GC code, and we can blow up everyone above us. I do understand that there are problems with templates, and we'll get into that, and closures and lambdas. So we can't make this like a hard rule that everything has to be done this way, but we're gonna start enforcing some of this, because this is not good. Template attribute inference. We never actually marked glob match as no GC. There's no, as I mentioned, there's no documentation. And because of this, the possibility for Heisenbugs exists. The function is both simultaneously no GC and not no GC at the same time, depending on what unit test block it's running in. There is actually a separate unit test block that is not declared as no GC in glob match. So like that's this is what we're dealing with here. Whether the method is no GC can change between releases. As I said, just remove that no GC on the unit test block, and you can do whatever you want. And this means that the API is effectively unstable. I understand that as long as you don't touch the unit test block, it'll work. But now we're requiring reviewers to know that this unit test block is associated with this. We're requiring anybody who wants to use this method to go read all the unit tests. And of course, you can never change this API back to GC again. The other one that came up that people really don't want to deal with, DIP 1000. It is so complicated that the number of people who understand this in D is minute. I can count them on one hand. It is designed to make unsafe activities safe, and any changes to like scope in either the return or the parameter list are breaking changes. So every single programmer working on Phobos 3 has stated that they have no interest in supporting DIP 1000. There are maybe 3 people in the D community who understand it well enough to use it successfully. All of them are compiler programmers. Only one of them wants to work on Phobos 3, and that person said no to DIP 1000. So that's where we stand with DIP 1000. So these are the banned attributes now in Phobos 3, because we simply cannot guarantee that these attributes won't change or blow up or cause some philosophical difference between, well, I have like the fast version and the slow version, or I have the scope version and the non-scope version, or the live version, etc. So this is kind of how I'm thinking about the Phobos 3 API right now. Safe by default, trusted when necessary, system is disallowed. It's always garbage collected. There's no malloc. There's no reference counting, no pointers, scope, live, etc. And I promised Ricky that I would put an asterisk on the reference counting one. If you need to use reference counting internally to your implementation because you're tracking a system resource, that's fine, but no reference counting in the API interface. And we're going to use exceptions for all of our errors, return codes and stuff. We're not going to allow. This is just to make the API as simple as possible. This is the Phobos 3 is the simplicity philosophy. And now there are probably a bunch of people who are going, "Oh boy, I just took away all the control and performance out and of D, and I have ruined D." Or have I? Because this idea came out in Discord about 4 or 5 months ago. We are calling it base D or based. Base D is intended as kind of a compact, high-performance library for D that is limited in scope, focused on performance, not safety, and will attempt, where possible, to avoid duplication with Phobos. It was actually Mr. Mike Parker who originally had the idea, and he called it the kernel library for Phobos 3. And Phobos 3, of course, will publicly import symbols where necessary. The idea here is to split the performance sensitive code out into a low-level library where we can resolve this philosophical tension that exists in Phobos 2. You have Phobos 3, that's that's the library that we want people coming to D to use with their first program. You know, they're going to write, you know, their simple Python one-liner in D, or you know, we have that one-liner on the home page. That's what you're going to use Phobos for. If you want Weka-like performance, and by the way, to the Weka guys, your numbers blew me away. And I love the fact that you were able to achieve that with D, and we want you to keep being able to do that. And we actually are hoping to give this library, the playground, where people like you can come in and say, how can I get an extra instruction out of here to make it go, you know, just that one operation faster. So the base D API is system by default. There's no garbage collector. You have to use malloc or reference counting. You can use pointers, scope, live, you know, use it all. We want you to. And so there will be no exceptions as well. None whatsoever. You'll have to do return code, or if you have a different, you know, like an error message sync. Walter's talked about that occasionally. That will be allowed. The other thing is there won't be any D runtime in it. There's just nothing in D runtime that we could call that we would want to call. And frankly, we shouldn't need it. You will be allowed to call the C runtime, but we will, in order to keep it focused on that kind of kernel library idea, we will not be allowing third-party libraries. If you need to go do something like HTTP client or something like that, you're going to have to go up to Phobos. So these are the supported attributes in base D. Basically, at your module level, we're going to have no GC, no throw. We are going to enforce that this way. There will not be any, you know, we are not going to allow any of these things in any of the code anywhere. Pure methods will be allowed. If you want to have your scope parameters and your lib parameters, knock yourself out. But base D is not going to focus. It's not going to have the surface area that Phobos 3 does. You'll get algorithms. You'll get the metaprogramming. The numerics library will be in there. We should be able to do like your type cons type stuff. That should all be in there. Date time, we can probably get in there, and this will actually probably resolve one of the difficulties of the way D runtime is currently built, because D runtime will actually be able to call into base D. because there is no runtime in base D, so there's no violation like circular references and stuff. String manipulations. I had to ask Ricky about this. We can do almost everything except the UTF spec does say that you have to use exceptions, which we of course cannot do in base D. So that is a spec violation that we probably end up just taking on. And one of the things that we can actually do is we can actually take our existing file IO in STD IO, and we can push it down into this library so that we still keep that API around for people who like working with it, or that fits their performance needs, et cetera. And console IO will also be more C style. So Walter, if you want your printf-like method, it needs to go into base D, but we can have that conversation. And the final slide, I apologize if I've rushed a little bit. I don't have a clock sitting in front of me right now.
5 minutes.
5 minutes? Okay. So the final slide, this is an idea that actually came out of BeerConf. So guys, if you're not attending BeerConf, you need to show up, because occasionally we actually talk about really cool ideas. And that is this concept of a platform layer. Right now, our platform bindings are kind of mixed in with D runtime, and they're all part of the core namespace. And so what we would like to do is we would like to pull those out, update them using import C, which has gotten just massively better over the past year. Thank you to Walter and all the other folks who have contributed to import C. You guys are making my life much easier. And so instead of having like core.stdc, you would have platform.stdc, and then this can be used by any layer of the ecosystem. So base D can call it, D runtime can call it, and of course Phobos can call it directly. And this will actually allow us to shrink down the core namespace to something that actually focuses on D runtime. And this is what the Phobos 3 technology stack actually ends up looking like. It's very simple, just up and down, just platform, base D, D runtime, and Phobos 3. So that is my talk. Thank you for listening, and I need to give a shout out to the tech team here. You guys are doing an awesome job, and thank you for working with me. I am very much missing being at DConf right now, in part because of the circumstances that I had to go home are nowhere near as fun as what would be going on at DConf right now. I also need to thank Delta for being able to get me home in time to be able to do this with you guys. And yeah, if you have any questions, there's my contact info. It has been a long day for me, so I can hang around a little bit in Discord after this, but I do need to get off to bed here soon. So yeah, thank you. Questions?
We miss you too, Adam.
Oh, thank you.
Yeah, my best wishes for what's happening at your end. Well, I think that the work you guys and the Phobos team are doing is there are a lot of innovative ideas in there, and it's looking pretty good to me, and I look forward to your first release of it. I think it's going to be awesome. So thank you to you and the rest of the Phobos team.
Oh, thank you. You're welcome. We've enjoyed arguing about it on Discord.
Any other questions?
Hi. So when you said you guys are probably saying you're ruining the, I know who you're talking about. So it sounds like a great restructuring, but we are, in a lot of our codes, restricting ourselves to the no GC part. And I was wondering more concretely, what will we be missing out on in the higher layers that will not be accessible in the Phobos layer?
So for the moment, and we can negotiate all this. As I said, join the Discord. Think things like data formats. We do a lot of allocation in there anyway. So getting those down to designing an API that can do allocation without actually being no GC is quite difficult, and the APIs get really ugly. We actually looked at doing this, and the APIs just got basically unusable. So that's an example of something that we might, and right now the current implementations of the data formats are also using the GC. So that's a major thing. Also, things that use third-party libraries or do lots of allocations, so like we mentioned third-party libraries. Getting something like OpenSSL into base D is going to be a monumental lift. And the APIs, again, because of the buffer allocations and stuff, you basically should just use the C API at that point, because you're really not going to get anything better using D. So that would be another area. Things where you're going to be doing allocation, lots of allocations, or dynamic array expansions, that kind of thing. So does that answer your question sufficiently?
Hey, Adam and Steve. I
Hi,
had
Steve.
one comment. I think that I much prefer expression type to property type. They're not that much different, and property type just doesn't sound right for things like local variables. So that's something I would suggest revisiting. And the other thing is...
Oh, well, yeah.
The other thing is that...
Okay.
Yeah, so it was more of a comment than, we could talk about it later. But the other thing is that when you talk about including IO pipe, that's kind of considered like the target is like high performance IO. And the way you talked about base D, it kind of sounds like it should go there, but by default, it should be allocating with the GC. And so you have these possible library pieces that, because it can accept an allocator to say, okay, just use malloc for your buffers, and that's fine. But where does it go? Because if you put no GC at the top of the file, then you can't use it with a GC allocator.
Yeah, so one of the things that we might have to do with that is wrap it in a closure and send the allocator down, and then build a wrapper API on top of it that sends the GC. That was actually our original idea for how to handle this problem in Phobos. But this philosophical problem kept cropping up where we're trying to do both in the same library. And you end up with things like glob match. So some of this will have to be taken on a case-by-case basis, where we look at it and say, well, IO pipe needs to be in base D, but we obviously we can't support the GC down there. Guys, there's still a lot of discussions going on exactly how to tackle this, but I don't know. Maybe IO pipe is fine in Phobos, and we just have a really high speed IO implementation in Phobos.
Any other questions?
Yeah, with regards to BaseD, how does this, like the problem with a lot of the Node.js stuff has generally been callbacks into user code. Is BaseD just not going to do, just not going to have that? Is it just going to be internal execution and all the callbacks are headed up to Phobos tree?
Oh yeah, the Lambda problem. Probably the most vexing problem we have right now is around template inference and exactly what you're talking about. BaseD is designed for performance, and handing over, control of user to a closure comes with a cost. And so we might look at it and say, yeah, you can't do that here. I understand that the rules around Phobos 3 look a little strict, and they will result in some arbitrary looking distinctions. And Jonathan and I have gone back and forth on Discord for hours, over days and weeks. I mean, even what to do about ranges, because there's parts of it that have to support the GC, but most of it doesn't. So how we handle that is going to honestly come down to the specific implementation that we have to write. So there might be parts of ranges that are not available in BaseD. Like, that's just not a thing you can do.
Mic on. I'm just going to say that this is the basic idea, the basic plan of what we have at the moment, of how we're splitting things and trying to organize it. Most of this is not even vaguely implemented yet. And so as we get into that, we're going to have to work out how to deal with some of these problems. In some cases, we know roughly what we're going to do. In other cases, when we get into it, we're going to have to figure out exactly how to tackle it. And some things may change. So we do need to know what some of these problems are and plan on tackling them. But at the same time, we can't say that this is exactly what we're going to do with this piece or that piece, because we haven't gotten far enough along to definitively say what isn't going to work and how it's going to be split. This is just the basic idea of what we're doing and what we're planning, and plans may change based on what actually happens when the rubber hits the road.
I completely agree with you, Jonathan.
Unfortunately, we have time for only one more question for the live stream. Sorry about that.
Yeah, Ate Eskla said, will Malik cease to be Node.js in platform-based D, since you said Node.js should just be no heap allocations? Or maybe
you're talking pure Malik?
Yeah, I think that was the question. Is our allocations going to be allowed in those levels?
So platform GC is supposed to be import C bindings to C libraries. And if you're doing anything else in that library, we should probably be rejecting it, unless it's like a template to, implement a macro or something like that. But like it really just needs to be the C header in D.
Okay, thank you, Adam. One more round for Adam, please.
Thank you, everybody.
We have another 7 minutes until the next talk starts. Oh, and before I forget, we still have slots for the lightning talks. So if you have an idea for a lightning talk, just tell me. Okay, so our next speaker had a very controversial talk last year, if you guys remember, where he, for like 90 minutes, transformed himself into the punching bag of the community. This year, he's back with a less controversial talk, hopefully. So everyone give it up for me. Yeah, so when I started contributing to D back in 2016, like communication was kind of a bit of a weird thing, right? So people in the community and also kind of the leadership of the foundation, they were communicating through emails, forum posts, PR discussions, or maybe even on bug reports, and maybe occasional phone calls between Walter and Andre and some meetups, but they were by no means like an organized, recurring form of communication, right? And discussions were almost entirely technical, right? So people wouldn't really discuss about, how to organize work, how to plan ahead, like what is the order in which we need to deliver features and stuff like that. And this had a lot of shortcomings. Like, for example, there wasn't too much alignment between people. Because what would happen, like if it was, for example, a bug report, someone would come and maybe present like the way they see the fix should be, and then some other supporters would say, oh yeah, that's definitely the way you should do it. But maybe that bug report didn't get the attention of one of the core language maintainers or someone with decision power. So what would happen, someone would just see the bug report, like let's say your average contributor, they would try to fix that issue, and at some point, someone from the leadership would just come and say, well, this is not the way we should do it. And this actually happened oftentimes, like, because you had like a group of people talking in some medium, which maybe other people just really didn't see it, right? So it was kind of hard to align all people to a certain vision. The other issue was that it's just the nature of writing, right? It's really easy to misunderstand what somebody is writing. So you would end up with having like forum posts with, 1,000 replies where people would debate like everything to the core. And I often felt that these discussions, and even Walter, I think at one point said that if we had like a half-an-hour phone call, like we would see that we're on the same boat, we're on the same page. So this naturally led to a lot of frustration. We also had like very prolific contributors leaving the community and abandoning us because of all of this misunderstanding. And it's really hard. We're not such a big community, and every person in this room is very important. So if someone decides to abandon the project, that's really, really bad. And now to give you a concrete example of this bad thing in play, it was 2019, and we were applying for GSOC, and someone had the idea to replace some functions in the C standard library with some D versions in D runtime. So I'm not here to discuss the merit of this proposal or something. It's just an example, right? So what happened was this project was published somewhere in one of our repos as a gist. A student saw it. He thought that he wanted to contribute to this. We actually got accepted to GSOC, and by the way, that was the last time until this year when we got accepted to GSOC. He started working. He started making PRs, and when the PRs landed, like some of the maintainers saw them and said, like, well, this is useless. We don't want this. And again, we shouldn't debate if what is the merit of this proposal or if we should have done it or not. But it's clear that we had like a big problem of communication here. And it was really kind of disastrous to our image, right? It seemed like, anyone can just propose something, then somebody spends some time, spends some work, implements something, and then it just gets turned down, right? So now, since that time, we've made some progress, right? So nowadays, we have monthly meetings. Amongst like the foundation members, we have agenda items, we discuss them. We also invite sometimes community members to participate, right? So this is like more transparent. Discussions, or at least transcripts of the discussions, are made publicly available on the forums. So we kind of trying to align everyone. so that everyone knows like what we are talking about and what the direction is. And we also have like bi-weekly meetings, the pull request managers and the project coordinator and Mike, so that we just have this exchange of ideas and take the pulse of the community and see what's happening so that we have like better communication in our community. But the discussions, again, are mostly technical. We rarely talk about organizing work. So let me just give you an example of a typical cycle on what happens. So on a specific day, someone posts, it's year X and D still doesn't have feature Y, right? I'm using templates here because I know you guys like templates. And then someone brings it up at one of our foundation meeting, right? And the typical responses are something like, oh, I thought T was working on this. Oh, or if T is present, oh, yeah, I totally forgot about that. Or I don't know, I was very busy. And that's totally normal, right? I'm not pointing fingers. Like most of the people here, they do D only in their spare time. And yeah, sometimes priority shifts or stuff like that. But there's also like some times where nobody actually remembers. It's like, whatever happened to that feature? Well, we don't know, because everyone is like kind of focused on what they're interested in and the projects that they work on D, right? But then like we want to move forward, right? So somebody eventually volunteers to implement. I mean, it also might happen that nobody is interested in that feature, so it basically just gets delayed. But most of the times, people volunteer to kindly fix that. But then some time passes by, and it's year X plus, another forum post appears, and it's like, it's year X plus N, and D still doesn't have feature Y. And eventually, we just restart the whole process to line 2. So there is a fundamental issue here, right? And the problem is that there is no follow-up, right? And again, I'm not pointing fingers. It's natural for people to sometimes shift their priorities and forget to work about things. But we as an organization need to know like what is the status of a project and to basically know if something happened and someone abandoned the project or something happened and, I don't know, progress is not that much anymore. So that is when the project coordinator role kind of came to be. And this was all Mike Parker's idea, and I want to like make a parenthesis and make a shout out to Mike, who has put like a tremendous effort to make all of this conference possible. And he's also always very involved in doing a lot of things, and I feel that most of the times like his efforts maybe are not that visible. So maybe we can give a round of applause for Mike. Yeah, so he had this idea to have this role where basically someone keeps track of all of the projects that are going on, and kind of asks people about like what is your progress. I often think about this role as being like a professional nagger, right? You just nag people like, hey, what have you been doing the past 2 weeks? So what was the progress? How was it? So yeah, you just poll people that are assigned to specific projects so that you know. I mean, it's not a problem if no progress was made, or it's not a problem if you don't want to work on this anymore. I mean, it's volunteering work, right? You can't make people do something, but at least we need to know, right? Because then we know what to do. We can find someone else. Maybe someone from the foundation picks it up. If we don't know, then that is kind of the worst case, right? So also the purpose of this role is also to remind what our goal and focus is during these meetings, right? Because it's really easy to start debating like some technical aspect of some specific feature and kind of, forget like what is our plan here? What is the direction in which we are moving, right? And yeah, a third aspect is you need to find people to implement these projects. Now, how do I view this role? Well, essentially, I kind of think of it as having a list of projects, and I just, get the pulse of these projects every now and then, and I also make sure that people that are involved with the foundation don't forget about these projects. And To that end, I kind of have two categories of projects. To me, they're kind of the same list, but it kind of helps to have them in different bins. And one of the categories is poster projects, right? So poster projects, they are revised annually, and it's essentially like these projects make good PR for us, right? So we want to kind of tout them. We want to show that we're making progress on them. And at the end of the year, we're going to have like this report and say, look, for these projects, this is where we were when the year started, and this is where we are now. And yeah, we'll see what we're going to do with this from now on. And the second category is strategic projects. Again, I track these projects, but like we do periodical updates on them, but they're not like the poster projects where we advertise them so much, right? And yeah, I do periodic updates to the community just to make sure that everyone is aligned, right? So it's like defining a list of projects, making sure that we actually make progress on these projects, and then inform the community and, you know, debate about certain aspects, and eventually maybe getting the community engaged so as to they make contributions to these projects. Now, what are the poster projects for 2025? Well, we have some types, and there is a dip that Walter made in November 2024 for some types, which I think is a rehash of a former dip. But the dip hasn't actually started the formal dip process, so we don't really have an implementation yet. So on my scale of red to green, where red means no progress at all, to green, like the project is completed, it gets a yellow. Then we also have DIP 1000, and DIP 1000 is kind of like a, you know, kind of tough topic, because as Adam also said, it's kind of complicated, and we don't really know what we're going to do with it, right? So it's here at the poster projects because we really need to kind of, you know, get to a decision. What are we going to do? Are we going to enforce it and maybe make it become the default? Are we going to drop it? Are we going to re-engineer it? What are we going to do with this? And unfortunately, we haven't really made that much progress, right? So DIP 1000 is kind of in the backstage right now because Arch64 backend, which is Walter's baby, I think kind of gets his entire attention. And Walter has been making progress on this. It's probably going to be another 1 or 2 years before we can actually use it in production.
I hope it was sooner than that, I hope.
Yeah, either way. So it gets kind of like, you know, a yellow-green, so we're making progress there. Editions, we have the dip. As far as I know, the dip process should have started for editions, so all of the details have been ironed out. Dennis is tasked with implementing this, and I think that maybe by the end of the month, or anyway this year, we should have editions landed. So it gets like a light green. It's almost done, but yeah, it's not actually done, but we're almost there. And then we also have move semantics, which was completely implemented by Walter. So this is a win for us, but we still have until the end of the year to make progress on all of these. Now, what are the strategic projects? We'll just start with some that have been completed. So it was the Bugzilla to GitHub issues migration, which was done by Robert Shadek, and this was completed. We are not using Bugzilla anymore to file new bugs. We have the migration of DPL docs to D-Rank servers, which was done by Vladimir Pantalev. Thank you. And then we have like another list of projects. I'm just like going to enumerate them, and then we'll talk a bit about those. DMD as a library, the new GC, Phobos v3, the release process, and replacing the runtime hooks with templates. So DMD as a library, this is kind of my baby. I've been working on this for some years now, and also Nicholas has been working on this, and as of recently, he has done the heavy lifting. There was also some great work done by Matthew Q. So lately, in the past 1 or 2 years, mostly the work on DMD as a library was to separate semantic routines from AST nodes. This was really a lot of work because like the code base is really large, and there are some situations where it's really not that obvious how to do this separation. I'm not gonna go into the details because I actually have a talk from like a few years back about this, and I don't really have that much time to talk about this, but we are getting close to finishing this, and after we separate the semantic routines from the AST nodes, we will be able to get rid of the duplication in AST base, if people are familiar with that. And once we do that, we will be able to define the interface for DMD as a library that will allow us to override whatever functionality we want, right? So just a couple of sentences. Right now, DMD as a library is usable, but essentially you have parsing. You can do parsing, and you get an AST, and then you can use it, right, for whatever you want. But then you can use the AST only after you've done the entire semantic pass, right? And when you get the tree after semantic, the tree from the parsing phase is very different from the tree from the semantic phase, right? So there's a lot of things that happens during semantic that currently you cannot override with the interface of DMD as a library. And separating these semantic routines is going to allow us to provide an interface which will allow us to do exactly that. So an ETA on this, actually, I have no idea, right? So this project has been going on for, I don't know, 7, 8 years. Progress is very slow. We've been using students. They work a bit, and then they leave. Then I sporadically do some work, and then someone else picks it up. So we don't really have like a champion who is working like all of the time on this, but eventually I think we will get there. New GC. So Steven is going to have a lightning talk about this, so he's going to have more details about this. He's the person that is assigned to this. I know that Amaury also worked on this, but like as of lately, the updates, I only get them from Steven, so I don't really know exactly how involved Amaury is right now. So my understanding is that now the GC is usable. So if you are on Linux or Windows, you can use it. It's available as a dub package, and essentially you can pass it. I know that Symmetry is using an LDC version of their own, which has this new GC, but there still is some work to fully integrate it in the runtime, right? So there are other OSs that need to be supported, but from what I understand from Steven, somewhere around 2026, we should have it fully integrated in the runtime, right? Phobos v3. So we had 2 talks, which were about Phobos v3 lately. As you probably know, Adam Wilson and Jonathan Davis are championing this effort. So my understanding is, and this information should be fresh from Adam's presentation also, but the plan is kind of like get the foundation going, which is STD meta and STD traits. Once we have that in a good shape, then ranges need to be ironed out and implemented. And Jonathan really wants to get them correctly so that we have a solid foundation. And once we have this, we can move over to porting and implementing the rest of the library. And at that point, we will be able to kind of parallelize the effort. ETA, we don't really know. I mean, I pushed Jonathan a bit for giving me like a timeline, but I understand that it's kind of hard to give one. I mean, I'm in charge of DMD as a library, and I also don't have one. So yeah, that's fine. But it is my understanding that maybe several years from now, we're going to have like Phobos v3. OK, with the release process, so maybe most of you remember that we kind of had the issue with the release of 2.110. So essentially what happened there, Ian, who was kind of the single point of failure for the release process, had a personal issue and couldn't take care of this. And it was delayed for some months until Dennis hopped in, and he looked at the scripts, and he is now kind of sharing this burden of release manager with Ian. And he has like all sorts of ideas on how to simplify this process, both bureaucratically and technically. So the next steps is to implement this proposal. We already had a meeting with the foundation on this topic, and we are all in agreement. Dennis has also made the forum posts, and there is some sort of debate there. But yeah, soon, probably by the end of 2025, and probably I'm being generous here with the deadline, we will also have this. And the plan is to have more people involved in the release process so that we don't ever have delays in releases. For the replacing the runtime hooks with templates project, this is, again, like a very old project. I think work on this started somewhere around 2016. And multiple people worked on it, but like 3 or 4 years ago, Teo Dutsu started championing this effort, and he has constantly worked on this, and we've reached a point where all functions have been templated right now. So we shouldn't really have any hooks that are plain functions in the runtime now. What are they focusing on is doing like profile performance and memory usage, so that they kind of understand if they introduce some regressions and to actually fix them, right? And you've probably seen if you've looked at the forums, because Albert is also participating at GSOC with this project, and now he's doing all sorts of measurements. So I think that by the end of 2025, we will probably close this project, right? We will have it finished. Now, a few words about the GSOC and SEOC, because in my mind, this is kind of like the best way to attract people to work on specific projects, right? And the paradox here is that we really have a lot of work to be done, right? But we are always, like, we lack projects or mentors. And this is really a pity, because we are missing a lot of opportunities here. Like, for example, at GSOC this year, we got accepted, but we only had like 4 projects and 4 mentors. And this is a really small number. Like most organizations that are kind of our size, they have at least 10 projects, right? And it's really a numbers game over there. Like the more projects you have, the more mentors you have, the more likely are your chances to be allotted more slots, right? And even if we had like 4 projects, we had around 50 applicants. Maybe you've seen the spike in activity on forum and on Discord. Like students were all over the place, asking questions and learning about the language. And it was a really nice way to kind of put the language on the map there, right? But if we are not able to, capitalize on this interest, then it's really kind of a wasted effort. So eventually, we had only like 2 slots allocated. I don't know, there probably are, but from the organizations that I've talked to, you don't usually get like 100% slots, like for the projects that you apply with. So it's better to apply with as many projects as you can, but yet again, like the projects need to be well defined. You need to have mentors for them, otherwise they're just not gonna pick you. And like the last time we got selected, it was in 2019, where that problem with that student was. And I mean, I don't know for sure because they don't publicize the way they judge your application. But I know for a fact that they look at your past performance, right? So I don't think it was really good for our image when we just selected a student to work on a project, and then we said like, well, this project is useless, we don't need it anymore. Okay, so I really want to, take this opportunity to make you think about mentoring people if you're working on D-related projects. And the thing is, we can't really have like very hard projects because we're talking about people that haven't really contributed to open source and that are really at the start of their programming road, right? And it's possible that you have luck and you get like a very, very good student that can implement like something very complicated, but most of the times, like, you really need to have like simpler projects so that they get a hang of how it is to contribute. And then if it's a success, then maybe you can absorb them in your community, and then you can put maybe more complicated projects on their plates, right? And it's really not very time consuming to mentor. Like most of the mentors, they spend like 1 or 2 hours per week talking to their students and helping them navigate like the complexities of the project. But indeed, you have to put some time to actually define a good project and find the spots where people can contribute. And thinking about the talks that I saw yesterday, I see loads of opportunity where students can contribute to all sorts of things. So it's just a matter of if you are willing to put in this effort, that would be really, really great for us as a community. So now to conclude, I know that everyone is hungry and lunch is next. We have begun an era of organizational maturity, I think. We are starting to get better and better at, planning and having objectives and following them. And I can see, like, during the past months, I could see that projects are advancing and people are putting in the effort. And also, Google Summer of Code and Symmetry Autumn of Code are some of the best tools we have to attract people to contribute. And it's really up to us to, benefit from these opportunities and get as many students as we can. So that was my talk. If you have any questions.
This isn't quite related to your talk, but I wanted to take the opportunity. Mike Parker normally runs the conference, but he couldn't this time. And so Razvan has stepped up and is running the conference, and he's doing a fantastic job. So I want to give a good thank you to Razvan for taking over.
Thank you.
Any more questions?
Make it a good one, how Ethan says.
There's a question on the Discord from Serg. He says, make blog posts monthly, please. Blog is dead for a couple of years now, and these kind of posts is perfect for a blog.
Yeah, sure. I mean, Mike was, taking care of the blog posts, but from discussing with him, he often said that it's kind of hard to, get people to write blog posts. So I think that his attention kind of shifted towards YouTube right now. But yeah, definitely we'll talk about this and see if he's up to running blog posts again. Okay, I guess we can go to lunch now, so if there's no other question.
Hello. 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 Come on, some noise. Hello. Hello. Yeah, no, we're going to get everybody downstairs here in a so. Hello. Ah, come on. I've got more energy than you, and I've got a bad throat. Come on. Hello. All right. I think that's the best we're going to get out of this crowd. Yeah. So, hey, how about that Razvan earlier today doing MC duties and a talk? How about we applaud for that? Hey, is he even here to hear that? Oh, I'll have to do it again. All right. Yeah, what do we got? So I'm back on the microphone. I've kind of fixed my voice a bit, as you can hear. If I tried to describe to you guys what I did to do that, you might drag me to The Hague for violating Geneva Conventions on the spot. So just trust me, I did some stuff to my voice. But what do we got? Official things? Oh, lightning talks. We have 2 slots left. 2 slots. That means 2 of you people, you're going to have something good to talk about. Or maybe even some more bad jokes, but please, not the bad jokes, not the bad jokes, anything but the bad jokes. Yes, the bad jokes. Look at this guy down here. Armory of all people, jeez. Yeah, well, we've got a minute to go. I always mangle your name even when my voice is good, so let's see if I can get it right. Rui? Rui? Yeah, I think it's close enough. Say it, is your mic on? Say it again.
Rui.
Yeah, that's his name. 3rd time DConf speaker. I think we're about good to go. We got a good enough crowd here. You good to go?
Yeah.
Yeah, you're not nervous at all? No, you're fine. You're fine. All right, let's kick it off with some applause.
Okay, so hi, my name is Roy Margalit. I'll be talking about Arson, robustness sanitizer. So we're going to start with some favorite topic of everybody. Nasal demons, undefined behavior. Back in, I don't remember when, somebody asked what's undefined behavior, and the compiler, somebody answered that when the compiler encounters some undefined construct, it is legal for it to make demons fly out of your nose. And we probably don't want it to happen most of the time. And we probably ask ourselves, why did the specificators of the languages even bother making some horrible things like that? And the answer is it allows us to perform many optimizations. Now, one specific case of undefined behavior that I'm going to talk about is the data race. And we say that we have the program that has 2 conflicting evaluations have a data race, which means 2 threads access the same memory location, one of them is right, if they are not executed by the same thread, or they don't have an happens before, or they're not atomic. If any of it is not happening, then we have undefined behavior, and the entire program that we have is can go bonkers. It's broken. So here is a simple program. We have a global n equals 0, and 2 threads accessing the same memory location at the same time for some definition of the same time. And this is undefined behavior, and if you have this in your code, everything can go wrong from here. Great. So why it's good? Because maybe when you wrote your program, you didn't have really good access types. So for example, the hardware prefers if we would access things linearly, because it makes things easier to prefetch and work on. And your program works like first we access n at 4, and then n at 2, and then n at 1. And it's inefficient when things get bigger. So the compiler is going to try to fix this and reorder the statements. So we are going to access linearly everything. And as far as we're concerned in single-threaded execution, we cannot tell the difference which program the compiler executed, because we only see the summation, and the summation is going to be identical whether we made the first summation or the other one. But the problem becomes apparent when we have some watcher watching this value and seeing what it is at different times. And now all of a sudden, if we had some invariant that, unless we counted everything in this example, we are going to have an even number, now all of a sudden the compiler changed things, and now our invariant is broken. But we do want these optimizations most of the time, because otherwise our programs are going to be slow. By the way, the timer isn't working. OK, so this is such a prominent problem that some very smart guys created a program called TSAN for thread sanitizer that allows us to detect these data races so we can actually fix them. And the way it's done is basically we have a program, and we're just going to compile with GC or Clang and drop -f sanitize equals thread, and it's going to do its magic. And each time we execute a program, it's going to try a different branch that we take and see if anything's break in the process. So if I were to demonstrate this simple case with our simple program, which is basically the same program we had earlier, I have n++ done by 2 threads, and it's going to be races. So if we compile it with LDC, sanitizer, and we say that it shouts, yeah, this thing is broken, you have a data race, go fix it. So we're good. We know that we have a problem, we can fix the problem. Now, one way to actually get concurrency right is to use atomics. And the way to do it in D, as of now, because I guess I didn't pressure the language maintainers enough, is by using core atomic. And then we need to use this really horrible syntax where we say atomic load over X, or atomic store, or atomic op with compile times string to get specific behavior. It's really bad interface because you can easily mix atomic accesses and non-atomic accesses to your memory location. Nothing is annotated about X being atomic. It's a kind of worms you don't want to open. The correct way to do it is to have a proper struct that is just going to do everything correctly from the start. So you can type A equal X, and it's going to do an atomic load correctly over X. You can do X equals 42, and it's going to do the atomic magic automatically. This is the way to go, not with this. So I'm going to assume we are going to have this interface through the talk because it's easier to work with. Great. So let's consider what happens when we have atomic variables and use sequential consistency. Sequential consistency basically means we have a single memory and that we execute some interleaving of statements from the different threads. So yeah, it grows exponentially, but it's easy to reason about for the most part. So let's say we started with everything equals 0, and I'm going to execute the left thread first. So I'm going to write 1 to the memory, read the value of y, which is 0, obviously. And then I'm going to execute the right thread. I'm going to write 1 to y and read the value of 1 from x. Very straightforward. But another possible outcome for the program is that I could first write 1 to x, and then write 1 to y, and afterwards read those ones from both variables. Great. So you can convince yourself that the possible outcomes here are A and B are going to be equal to 1 and 1, as we've seen, or 1 and 0, as we've seen, or 0 and 1, which is the mirror image of the first example I've shown. But there is no way we're supposed to be getting 0, 0, since something has to run first. And if we are going to read 0 for y, it means that we had to write 1 to x first. But if we wrote 1 to x, that means that the other read of x is going to be 1 at this point. So we cannot get this, which is fine, except sequential consistency doesn't come for free. There is a price to pay. When we use it, the compiler is not allowed to reorder statements because the order is forcing stuff. It forces full synchronization between threads, and it can be harsh on the cache coherence algorithm because you're going to try to force changes on a specific memory location. So they figured out that, OK, we don't always want sequential consistency. We also want to support weaker accesses that are going to be cheaper and not provide as much synchronization, but still provide something. They're going to give us defined semantics, not undefined behavior, but I'm going to give up on some nice features in life. So there's release acquire that allows us for causal consistency. I have a typo here. And relaxed accesses. And if we need to restore synchronization, we can use fancies. OK, so far so good. Now, my atomic structure actually supports this. So the default argument for all the functions is basically do it in sequential consistency. So this is the way I would write it. But if I could have just replaced them with release acquire, and now all of a sudden the behavior of reading 0, 0 is possible. And the fun stuff is that possible or not possible, there's a question of how likely it is to happen. So if I have this exact same program from earlier with a loop that's just going to try to get the behavior of 0, 0, and let's give it optimizations just for fun. So yeah, anyone wants to try and debug programs that happen once in? Yeah, that's not going to be fun. Yeah, OK. We did it. It only took like 143,291 attempts to try to get this behavior. Anyone wants to try to debug something like this? No. No. Good. And neither do I. But the real problem becomes more apparent if we have a race that depends on this weak behavior. So the race is not going to exhibit itself for the most part. And you could have said, well, we have Tison. Tison can detect these races, right? Well, no. Because for Tison to identify these races, it's going to introduce its own synchronization mechanism, which means that we are never actually going to be able to read the behavior of 0, 0, which in turn means we're never going to be able to detect the data race. So I could be nice and show it to you, but you're going to have to believe me that it's not going to finish. Yeah. Oh, yeah, it requires set arch. So it's going to run, it's not going to finish. So let's just ignore it. OK, so just so we know how race detection works, there's this awesome mechanism called vector clocks that a couple of people devised over the years and independently, and it has been used for race detection and other things, which basically is the idea that we have a thread, and this thread is going to have times. And each other thread is going to have a view of what is the time for each other thread, which is going to be represented as a vector of these timestamps. So I know that thread 1 is a timestamp 7, thread 2 is a timestamp 42, for example. And then we have a program, and we have basically vector clocks for all the threads and for all the atomics. And for the non-atomics, we also have timestamps of when they were written by which thread. So we initialize it with everything being 0, except thread knowing about itself with timestamp 1. And then when we are going to execute stamp statement, we are going to update our reviews. So if thread 1 is going to write an atomic release operation, it's going to store its view as the view of the variable x, and then update its timestamp. And then when it's going to acquire, it's going to take the view of some other variable. And now when we iterate some, write some non-atomic, we're going to say that, OK, fine, the non-atomic n was written by thread 1 with timestamp 2. And this is what we're going to compare against to find the race. And similarly, the other thread is going to write and update its timestamp. It's going to incorporate the timestamp of x. And now this is where the problem happens. Under normal circumstance, if we were to not have this conditional, we would have noticed that we have a data race because we're going to have access n with, and notice that our view of 1 is lower than the 2 of the thread, and we identify that there is no happens before relationship between the writes, and would have reported the data race. But the thing here is that we read 0. We cannot read 0 from x, so we cannot enter the conditional, so we can never report that we have this data race violation. So there's the option of giving up on atomics, on weak behavior. There's the option of getting the simulation is really hard, so either we give up or we're going to pay a price. We can pay with unbounded memory overhead proportional to the execution left, because we are going to need to store an entire graph, and any read might be reading from some any other read in the graph, so we cannot even prune it, and it's going to use a ton of memory, and it doesn't scale. Okay, and the other option is just prune the tree and hope for the best. But then we're back at the problem that we're not actually fixing the program. We might be missing stuff. We might have data races, and it can affect correctness of the program both in space and in time, so it's not optimal. So back in DConf 2022, I presented my work about atomic variables, not radioactive, but you probably still don't want to touch them. And in there, I presented a tool called Rocker that does static robustness verifications for program, and it's done under sequential consistency. So for anybody who didn't watch the talk or doesn't remember the talk, a program is robust against the weak memory model if all the behaviors it could exhibit under the weak memory model are the same as those under sequential consistency, which means that if a program is robust, we can still get the better performance out of the weak memory model, but we only have to reason about sequential consistency, which is easier and solves a bunch of bugs. And to verify the robustness, we only need to worry about sequential consistency semantics. So it's actually something that's feasible to do. And the way I propose to do the weak memory model robustness verification is basically verify it's robust, verify it's correct assuming sequential consistency, and you're good to go. And Walter loved my work back then and said, you know, this really should be part of the compiler. And yeah, it took me a couple of years, but I did it. So it can now be part of the compiler. Not a trivial work, but amazing nonetheless. It works as an extension to TSON, which means it's an LLVM path. You're going to compile your program just as normally with the same flags and with the F-sanitized thread, and you're going to get robustness verification. You don't need to annotate your program. It supports the RC20 fragment of the C++ memory model, which is more or less what you have in D. We don't really have that many language memory models. So we have release, acquire, relax, the read, modify, writes, fancies. And if we have violations, we're going to get a backtrace so we can know how to fix them. And in the process, there's also an issue that TSON didn't support fancies and relaxed accesses, so I had to fix it as well. Oh well. So the first thing is, let's go showing it first. Anyway, see, you can see that TSON is still trying to find a violation, didn't find it, so let's just give up on that. And let's instead compile it now with I think it was there. No, that's LLVM, sorry. Really should have made sure it's there. Probably this one. Yeah, and it's going to shoot all these robustness violations that I just had. So it's finding them very easily. Anyway, so I wanted to compare the tool to the static approach. So I took Decker's implementation of a lock and want to see how fast can I find a violation. So the static approach takes more and more time the more threads I throw in the program. And the dynamic approach is basically doesn't see the difference. So it works. So it beats it in terms of time, cool. And in terms of memory, yeah. The static approach has to keep the entire search space in RAM. Not great, but it's at least ruined it. And my dynamic approach basically uses the same amount of memory. So great, so I can beat static, but it doesn't mean much, right? The question is, does it scale in the real world? Can it work on real stuff? Can I use Arson to convert programs that were written by someone to become robust? And you know what? I can easily transform any program to be robust. Just use only sequential consistency atomics. Then you're robust, and you're not going to have this issue. But we do want better performance. So one of the benchmarks I tried was basically the meme-alloc allocator. It's 12,000 lines of C code. It heavily uses atomics. The test code uses 60,000 distinct atomic locations, so I was basically tormenting my tool, and it coped. So yeah, I can scale to big stuff. Great. I also identified 20 distinct robustness violations. I was able to fix them one by one. Great, the program is now robust. So how well did I do? So it turns out that if I would have promoted all the atomic axes to be sequential consistency, I would have used 3 times more fancies than what I use. So we can actually run the same program with the same guarantees, but with many, many less fancies, which translate to better performance. So it actually allows us to balance between getting things correct and getting things to be fast enough. And the way I do it is with my innovative idea of location clocks, which instead of giving timestamp to threads, I'm going to give timestamps to locations. Otherwise, they work very similarly. And then, to understand it, we need to remember that our definition for not having data race is if we have a happens before relation. And the happens before relation actually differs between sequential consistency and the memory model, basically on what constitutes as an happens before. And the idea is that I track for each thread what's the per location maximal timestamp under the HB happens before for sequential consistency, and under the happens before for the C++ or D or Rust or whatever memory model. And the idea is that if at some point I'm about to execute a statement and these two views diverge and say that I can read different things, that means I have a robustness violation, since the weaker model can read something that sequential consistency cannot. So at this point, everything is going to go to break if we continue, and we're not going to be able to track it. And to track these relations, I need even more relations, where each thread, each memory location is going to need to know for its last write what is the maximal timestamp that's going to reach it with happens before SC or with the happens before. And since sequential consistency actually synchronizes through read relations, just like the example we saw earlier, I'm going to need to have a relation that says that what is the per location maximal timestamp that even accesses this specific calculation for sequential consistency. So if we're going to look at our run example, which is simplified than the entire string, which is more complicated, everything starts with x at timestamp 0. And then when the left thread is going to write to x, we are going to update its view. So both the view of the thread itself, that's the location itself of x updates that it has new timestamp, but also the view of the happens before relationship, both in sequential consistency and in D. And then when we load something, it's not going to update the view of what happens with a newer timestamp for y, since it was not written. But a side effect of reading the value of y actually updates the fact that the latest access to y now knows of this write to x. And when the write thread is going to write 1 to y, as a side effect, it actually synchronizes under sequential consistency, incorporated the timestamp of 1 to x to its view, while there is no happens before relationship in the D model, so that one doesn't get updated. And now when we're about to read x, we actually note that the two views diverge, which means that we have a robustness violation. So this is the idea of how we track things and identify these robustness violations. So to conclude, we propose a way to complement the standard dynamic race detection with dynamic robustness violation verification. And the robustness verification is immune to the observer effect. We've noticed that race detectors are prone to, because they introduce synchronization. And we are immune to it because we don't care about the synchronization, since we use sequential consistency semantics to begin with. Introduced basically the technique to do it, created a tool that is sound, complete, and consumes linear memory in the number of threads and atomics, and it scales against real-world programs and allows for defensive programming. Now, thank you for your time, and just a note that I was required. Presenting at DConf actually gave me my current job, and Weka is hiring. Thank you.
All right, let's see some hands. We've got some questions, right? Here we go, Bruce, up the back.
So I noticed you were referring to three times the fences, 1/3 the fences were required, and I was wondering, do you have any translation into actual observed performance? Is this a lot or minor, or how does it happen? I understand that it will vary with programs, but I'm just wondering if you had any performance data from actual programs.
So sadly, I do not, because benchmarking all this stuff is actually really complicated, and if you cannot get rid of all the noise, then it becomes really hard to actually see the difference. So I measure what I can.
Are you planning to upstream this into the LLVM TSAN?
Great question, and the answer is I'm trying to. I sent a message on the LLVM discourse forum, and I'm still waiting on Dmitry Vuyokov to make the decision to upstream this. Apparently, he doesn't have enough time, because even my smaller patch to just fix TSAN by itself, to be more correct and support relaxed access defenses, still hasn't been reviewed for the last 2 months. So if anybody knows a way to get Dmitry to actually look at this stuff and upstream it, that would be great.
Send the link to me. No, I just wanted send the link to me. I've been a LLVM contributor for quite some time, and I can, look it up and ping at the right people.
Okay, thank you.
I'm also one, so you can also contact me.
Yeah, I guess I should have put links on the slide.
About the Mimaloc, if I'm pronouncing the name correctly, from Microsoft, do these issues translate to actual bugs that can be demonstrated?
So the thing is, you can write correct programs using the weaker accesses, but unless you have some formal verification proving that you don't have bugs, then you don't know if you have bugs. And the idea is to try to prune ourselves only to sequential-consistent behaviors, which we can actually try, at least if we throw enough force at it, to find the bugs.
Do you believe that these things, did you try to analyze whether they are bugs, or you just said it's impossible to reason about this way, I'll just ignore it?
It becomes really, really complicated to reason about, and I researched all of this stuff, so. But you can recall the talk from 2022, where I showed how real professionals looked at the code and analyzed it and were completely sure that it was correct, and even introduced a new type of logic to prove the correctness of the program, and still managed to not prove the correct properties, and the program code still had a bug, even though they missed it. So this is why I try to limit myself to a safe subset.
Come on. One more good question. One more good question. We can do this. Here we go.
It's not sort of a question, but more of a call to sanitizers on LDC. I think this is something that is not on LLVM, and it's good to have it. But for example, we have a lot of other sanitizers that we like LLVM supports, but LDC doesn't. And would be cool to have someone adding support for it.
Mm-hmm.
Right, but like you said, that wasn't a question. So come on, one more good question. I'm sure you all have it in you.
I'll just note something about this. Basically, when I wrote the code, I wrote it against Clang for obvious reasons and tested it on C code. But converting my sanitizer to work on D was just trying to figure out to compile custom LDC with my LLVM. And other than that, it just worked. I didn't actually need to mess too much with D to get it to work right with D.
All right, this room looks asleep. I don't think they have one more good question in them. So, hey, let's just give the applause then. Thank you. I'll just do another reminder. Lightning talks. We still have 2 slots, right, Razvan? I don't think he's paying attention. 2 more slots to fill, and that's tomorrow afternoon, so you do have plenty of time technically, but hey, let's get excitement going. Lightning talks, lightning talks, lightning talks. How about half an hour of break? We're back here, and Amari, you've got your hand up.
Yeah, I'm going to take one of those slots.
All right, Razvan, did you hear that? Amari wants to do a lightning talk. All right, so we've got 1 slot left. You're taking a slot too. You already have one. Okay. Yeah. All right. Well, then I guess we've still got 1 more slot for the lightning talks. But yeah, like I said, we've got half an hour break to the next talk. So maybe someone will have an idea in the next half hour. I don't know. We'll see you all back here at 2:30 either way. yell some people up.
Which is why I'm not drinking tonight, because I can't do that tomorrow.
I'm just judging everybody for coming up at the right time. Congratulations. Yeah, I saw you had your hat yesterday. It's like, yeah, no, that's fine. Maybe I should bring my hat in as well. We're normalized hats back in the society, I think.
That was the only hat my wife would approve.
All right, it looks like we're all mostly back this time. I like it. Still lots of chatter though. Hello, up on stage. It's time to pay attention. I sound like a school teacher. Eyes to the front, please. All right, who we got here? Timon. You're a seasoned pro here. Give it up for Timon. Semantic tension, the edge cases of D's introspective power. Yeah, this one sounds interesting. Take it away.
Thank you. I'm actually surprisingly well rested today, and I attribute this to Mike during a DLF meeting saying that my talk will probably be on Tuesday. So I was almost ready yesterday. All right, so we've already had a few talks that talked about these nice introspective capabilities. So basically, this is enabled by templates. We also have mix-in, both code and template mix-ins. We have some features to query properties of the code. We have implicit function template instantiation. And importantly, we have conditional compilation, where you can generate or not generate declarations based on the queries that we make. So D has a few traits. They don't all fit on this slide. And a trait is basically a compile time function to query some property of the program. We will look at two examples. One of them is the ubiquitous traits compiles, which means you basically look at the expression that is given at the second argument, and if that compiles in the current context, then it will evaluate to true, otherwise it evaluates to false. Another important one is all members, where you can get all members of an aggregate. You also have traits to actually access the aggregates by string, and so on. And this enables a lot of things like we've seen. So for example, serialization or automatic upgrading between versions, stuff like that. Then we have static if, and basically the spec here says the static if body is compiled in if the condition is true, and it is not compiled in if the condition is false. And finally, we have forward references. So basically that means we can refer to declarations, for example, X here, before they're declared down here. So X is referred to here and here. Here we have a traits compiles that doesn't fire because C is simply not declared anywhere. And when we run this without generating code, because, well, we don't need to, we will get the 1 here because X is 1, and we get 1, 2 because X and Y are 1 and 2. Y is compiled in because X exists. Okay, so in all the following examples, we will assume that this is appended at the end of the example because we want to know which declarations actually exist. So is there anything controversial about the things that I've shown so far? Because I would argue, yes, there is. like the spec just states, if this symbol exists, this will evaluate to true. And it says, if this evaluates to true, then this symbol exists. So there is there's some fishy things going on because, well, there is no objective reality here. We're actually building it, right? So we will see some manifestations of this. So first, the least concerning one. So here we have x is declared, and then y is declared if x exists. And then, of course, x and y exist. We can also do it the other way around. You can declare x if y exists and declare y. And then both exist. But if we actually say x exists if y exists and y exists if x exists, something else happens. I mean, it's somewhat intuitive, right? Because for one of them to exist, the other one should first exist. But this does indicate that there is something else to understand than what we've seen in the spec, right? Because there seems to be some evaluation model here, some underlying evaluation model. It's not just about what exists and what doesn't exist, because otherwise there would be another equally valid solution, which is to just declare both variables. Okay, so this is a slightly different case. So if you didn't notice, the difference is that here we declare y only if x doesn't exist. And here x exists because we declared it, y doesn't exist because x exists. We can do it the other way around, and then y exists. We can also do both. And now this is the first time where I would say this is a bit concerning, because now the compiler just selects one of them and says the other one doesn't exist. And of course, this is a valid solution, right? But it's not the only one. It could be the other way around. Now, okay, so what I do now is I declare a new variable set at the end, and I wrap the first condition in does set exist. So this shouldn't change the program, right? Because we're just introducing a true condition. But actually, if you notice, okay, it doesn't. Yeah. So this is all valid. But now let's do it on y instead. Not yet. Okay. So first we will add a condition on set. So we only introduce set if y exists. And now this actually changes whether y exists. So because now we're asking, does y exist? The evaluation order of things changes, and it will first introduce y instead of x. And I mean, we didn't really do much, right? Before y didn't exist. Now we're asking, does y exist? And now it exists because we asked about it. Yeah, it's like before the compiler just didn't know that we were interested in y, right? But if we ask, hey compiler, do you have y? Then actually the compiler is very forthcoming and it will give us a y. Okay, so before basically we had a case where the compiler selected something, but an issue is that which solution the compiler selects actually depends on the order that you pass modules on the command line. So we have two modules here. We have module A and module B. They import each other. And then they basically constitute the same example as before, like one module defines X, one module defines Y. What is interesting is that now it's actually the other way around as before. So if we first if we first compile A and then compile B, then it will introduce Y. And if we first compile B and then compile A, it will introduce X. And so this has the potential to introduce some some issues or inconsistencies in a separated build if you're inconsistent about the analysis order of modules. And the analysis order of modules, I think, does not only depend on the command line arguments, it also depends on what is imported where. So this can potentially lead to some issues in production. We can also define code that just blatantly contradicts itself. So here we're saying if X doesn't exist, declare X. And unfortunately, this is something that's sometimes useful because you may want to say, well, if X doesn't exist yet, now I want to introduce it. But it's still not so clear what it should mean. And what it means with the current compiler is somewhat inconsistent. Because now if we ask for X above this declaration, it will actually not be in scope. So up here, this X is not found. But then down here, recall we added all those queries for X, Y, and Z. Down here, it exists. So now we have some sort of order dependency, and X exists in the same scope in some places, and in other places in the same scope, X does not exist. This is another interesting example. So maybe you need some time to parse this, but I will explain. So we have a function foo, it returns a string, and this string returns, and the string that it returns basically declares a static function foo that returns a string that would declare a method bar. Then here we have a struct s, and we mix in foo. So if you don't know what mixin does is it evaluates this code at compile time, it gets a string back, and then it interprets the string as code. So what happens here is this lookup of foo goes to this function foo, right? Then it inserts this string. This means it will declare a method foo that returns the code for a method bar. And if we query the members, we see, well, yes, S has a method foo now. Now what happens if we mix in foo twice? So what actually happens is that the first lookup of foo, it goes to the outer method. But now, because we have mixed in a new static method foo, the second lookup of foo in the same scope will now go to the other method, the new method, which will introduce the method bar, and so S now has both foo and bar. And of course, when things change in your program, the thing that you're usually most looking forward to dealing with is caching. Actually, I inserted some more stuff here, I'm sorry, but let's go to caching and then go back. Okay, no, sorry. It is not about this example. All right, so let's just continue. So we have aliases here. Alias A is foo, alias B is foo. And they're actually not the same, right? Because before the mix-in, the foo is the outer one. After the mix-in, the foo is this one. So we have two aliases in the same scope. They are declared as exactly the same thing. They're not the same symbol. We can also add here at rates compiles. So we can ask, does alias B exist? And in this case, if we introduce alias A only after we've checked that B exists, they will actually refer to the same symbol. Here is another interesting example. I mean, I already spoiled it if you can read fast enough, but who thinks the static assert will always pass? Okay, I've primed you sufficiently well. Who thinks the static assert will sometimes fail? Okay, so most people don't know. So the static assertion can fail because it has a feature that's called overloading. So we can actually introduce a new overload of foo that is a better match for an integer. So that means that while this call calls this function, this call here will call the new function that is introduced on the condition that itself returns 1. And well, now it will return 2, and the static assertion phase. Okay, so now we'll finally come to caching. So in D, we have templates, and every instantiation of a template is so every instantiation with the same arguments is the same symbol. So that means there's some caching mechanism in the compiler, and we can actually invalidate this cache now because, well, facts about the program change between different queries. So here, we basically have this template that acts as a cache for foo. We call it with 1, and then we assert that it's the same as foo of 1. And this assertion actually fails, even though it's like literally the same code that we see in the template declaration, because of the way we first instantiate it and then introduce a new overload. So this thing actually refers to the overload that's further down here, while this here is an instantiation that still uses this method. I don't know why it does it in this order, but probably because we have to, well, I don't know. I tested it and it fails. Sometimes we will also just get something that doesn't look like a solution to the set of constraints that are defined by the static ifs. So here we have a trait compiles X, then we put in Y, and if there is no C, we put in X. And what DMD does here, it only introduces X, even though if X exists, there should be a Y, right? So what did I change here? Yeah, I just changed the order of the two static ifs, and then it will introduce both. So, okay, so let's take a step back and think about what could D do, other than what it does now, which I'm not entirely sure what it does because it's not documented. So one proposal people often come up with is just use a fixed evaluation order. The issue is this breaks forward referencing. So forward referencing is sometimes useful, and it was sometimes useful even in those examples. And we would kind of need to define a global order on modules to always analyze them in the same order. And that is tricky because you don't always know which modules you're going to import in the future. Another dummy proposal is just set it up as some sort of constraint satisfaction problem, check if there is one and only one solution, and then use that. The issue is this is infeasible, so it is infeasible even more than this, but we can reduce it. We can reduce unique 1 in 3 sets to this, which in turn has a reduction from 3 set, which means this is an NP-hard problem. So basically how this works is we have all those clauses. 1 in 3 set means one of them is positive literal and the other ones are negative. And we can directly encode this sort of formula where we say, well, if x1 and x5 both exist, then that means x3 must exist, otherwise this clause is unsatisfied. And if you recall, all the clauses have to be satisfied, and in each clause, one of the conditions has to be satisfied. So another thing that D could do that other languages sometimes do is explicit staging. So basically you put every snippet of code in a certain stage, and then you can only reflect on code that is in a lower stage. The issue with this is that there's some annotation overhead, and it's suboptimally modular because now you kind of will need to annotate stages across modules to make everything compile together. And of course, it may disallow useful code. So another thing I thought about was to track dependencies and then just analyze the code until you're not certain anymore about anything. And then you kind of start forcing decisions. And then if later it turns out that those were the wrong decisions, you just say, well, I screwed up, or more nicely, from the perspective of the compiler developer, you can say, well, the program you gave me doesn't make sense. It tries to undo something it did before. So this can be made source order independent. So no matter in what order you analyze the same code, it will always give the same result. It is still dependent on nesting order. So if you swap around two nested static ifs, I think this can still result in different results. But an upside is that it only produces consistent solutions. So whenever this compiles, you know that there is some consistent assignments to symbols existing and not existing, and whatever artifacts that are consistent with what is written in the source code. Of course, this is also somewhat restrictive, so it also sometimes disallows useful code. One benefit of this is because it ensures that decisions do not change, we don't have cache invalidation in templates. We can also think somehow about hybrid versions to allow some more things in some cases based on source order, but I haven't explored this much. So here's an example for analyzing anti-saturation. So here we have that like Y exists if X exists, and C exists if W exists, X exists if C doesn't exist. Well, W is not mentioned anywhere, so Z doesn't exist, right? But and then X should exist and then Y should exist. What DMD does here is the same as before, it says just X exists. What we could do instead is, I've said this is like A, B, and this is C. And you have that A depends on B because, well, B can introduce X, and it can introduce anything, so we will treat the mixin as opaque. It can introduce a declaration of any name, which also means that this last static if depends on B, even though it asks for W. In principle, a mixin could introduce a symbol that's called W, right? So we get this dependency order between the static ifs. We have that A depends on B, C depends on B, and B depends on C because, well, C introduces Z that it's asking for here. And now you already see we're stuck here, right? Because B depends on C, C depends on B. So now we will have to force some decisions. And what we will do is basically, we don't know about Z, we don't know about W. So we will say both do not exist. And because W does not exist, then Z is not introduced down below. And we will just note those on the side. So the compiler will keep track that it decided that those symbols don't exist. It introduced X and it mixed in K. And now it freed up A, right? A depended on B, but B is resolved now, so we can do A. And then it will introduce Y. Y exists now, and this is different from what DMD did, which said Y doesn't exist in this case. For contradictions, we can do a similar thing. So here, if X doesn't exist, we introduce X. So first, we get stuck because we don't know about X. Then we say, well, we decide now, we make an executive decision that X doesn't exist. And now X is introduced, which means we will say, well, no, this is an error. X is now introduced, even though we have already decided that it shouldn't exist. So I've more or less implemented this in experimental D front-end. So it explores this saturating to, this analyzing to saturation. And it does it iteratively. So you may need multiple steps of forcing decisions until everything is analyzed. And this actually started out as a Lexer and parser for D, which is the first side project I did in D. Because I wanted to learn the language, right? Actually, I started using D before I started using automated version control. So I just had a few folders with different versions of my frontend until like 2013. And then I committed them all into a Git repository, which unfortunately means you don't have time stamps anymore on those commits, but they're all separate. It is, of course, very incomplete, so it won't compile your code. It won't even compile the runtime or Phobos. And it doesn't compile anything anyway, it just type checks it. It does some things better than DMD, and it doesn't do some other things at all. And I would, again, like to stress that this is my first D project. So if you're going to be like offended by anything you're going to see, that will be my defense. So Let's just get right to the offensive part. So how is it implemented? I use some sort of compile time visitor pattern. I will explain what this means right after. We have a single reentrant method for semantic analysis. So I don't know if you know, but DMD is like semantic, semantic 2, semantic 3. And then at every stage, the AST is supposed to be in a differently strongly analyzed state. In my front end, there's just a single semantic method. But it maybe will be called multiple times. And it also has to be reentrant because maybe it will recursively call itself. And conceptually, we treat every AST node as a coroutine, while in practice, most analysis is handled by direct recursion. But we have an explicit scheduler that detects and resolves the cyclic dependencies that may arise. And I have various string mix-ins to automate this in all the implementations of the methods. So here is how this compile time visitor pattern works. So basically, we have a mix-in template visitors. And this mixes in the different visitors that you can have. The visitors are not a runtime concept here. They're just a compile time concept. We have a mix-in template for all the semantic routines. We have one for analyze, which is just an ad hoc visitor that you declare at compile time, and then it uses some compile time introspection to run the analysis. We have one for CTFE, so that the front end actually has CTFE. And we have one to duplicate the AST node in a deep fashion. And in every node class, we just mix in all the visitors. And then we have different files that have the respective implementations of all the recursive routines. One benefit of this is that these visitors can actually introduce fields in addition to methods, which I think is quite nice. So here you can see this is for AST rewriting. Basically, I don't want to track all the places where a node may be referred to, so it's actually lazily rewritten using this field. We have some current state. In the beginning, it's begin. In the end, it's completed or error. We have this need retrieving, and this will be set to true when we get stuck on some other nodes that hasn't been sufficiently analyzed. And this means that the scheduler will need to restart this node at some point. And here we have the semantic routine, and for node here, by default, we will just say, well, this feature is not implemented. We have a mix-in to set up like the node to be registered with the scheduler. We return if the node has already been completed and doesn't need to be analyzed, stuff like that. And we have this method, no hope. This is called when an analysis gets stuck, the scheduler identifies a set of nodes that you can tell, well, whatever you're waiting on, it's not coming. And we do this for all the AST nodes. So we have here nodes, expression, and statement. So what are the trade-offs here? Pro is conceptually, it's quite nicely encapsulated. We have everything related to one of the analysis routines or interpretation in one file. It's like a visitor pattern. It's a bit nicer to use because you can actually do compile time introspection. You can have templated return values. You can have different types of return values. This is all not possible with virtual methods. You can add, as I said, fields right to the related methods, the related visitors. You don't have to like separately add fields to a different file if you're working on a certain visitor. That means everything related to one method is in one place. We can also add some mixing templates in parent classes as some sort of customization points, and then in all the child classes we can mix in this mixing template, and in other nodes it's not directly accessible. We only need one virtual call to evaluate a routine. We have all information available at compile time. We can implement a virtual method for different template classes at once, so that gives you some sort of trade-off. So you can either say, well, we will write different methods for different AST nodes, or we can just bunch them all together into the same mixing templates and then use static if, so you can do whatever makes most sense, as Dennis said yesterday. The con is, of course, that the actual encapsulation is completely terrible because template mixins are unhygienic. This means anything you will need in any of the visitors, you will need to import in the ASD module. And the ASD module, of course, has to import to get access to the mixin templates all the other modules that define the visitors, which means basically everything just imports everything. And visibility modifier meanings don't correspond at all to code organization, so you can't just give up on private, basically. And of course, I wasn't entirely honest, so I will come clean now. This is what the visitors mixin template actually looks like. So we have like 3 workarounds for DMD bugs here, and I had to change the order of certain things. I had to move certain methods directly into the ASD class, and so on. Yeah, so maybe you don't want to do this. It's really nice, but it doesn't work. So now that I've come clean about the state of the code base, let's just dive right in. And have a look at what I did. So this is the Lexer. It first defines all the different types of tokens that we have. So some of them are so-called simple tokens. And actually, so here, those are all the tokens that exist. Then it automatically implements some things related to this. So in the end, we will have some template that is called talk, and then we can just do, for example, here to get a left shift token, and it will automatically select the right enum member, stuff like that. And we have this case simple token helper function. It is down here in the middle of the Lexer, so this is the big switch statement that dispatches on the next character, right? So this should look quite familiar if you've ever written a Lexer. And for all the simple tokens, this is actually done with the string mixins, the string mixin. So it is implemented entirely here in this method. And we can actually print the code that it generates. So as you can see here, it automatically creates all the switch cases for all of those simple tokens that don't have any other data associated to them other than it's this token. Yeah, then the Lexer feeds the tokens as a range into the parser. And the parser also uses quite a bit of compile time introspection and just code generation. So here's the implementation. I was, as you can see, as a novice programmer, very concerned about symbols that are only used for CTF ending up in the executable. So I did a lot of things with templates that you could just do with the CTF function. And here you can see how it's used. So basically it says a type and a name, and then it automatically selects the right method to parse the respective thing and introduces this name into the scope. So we can now use it. And then it has various additional features. We also have this rule that directly returns it. So to parse an assert expression, I just have this rule, assert exp. Then it says there should be, so this says basically the assert exp that doesn't need to have a name, I think. Then here we have an opening parent. Then we parse an argument list, and then we have a closing parent. Stuff like that, right? This is how the parser works. It's almost complete. I think it cannot handle things like external attributes on function types. Then after we have parsed, there is a semantic analysis. And this is my favorite template in semantic analysis. You can see this is a mixin template. It is generated by mixing in code that is generated by mixing in code. And then we do this a bunch of times to get nicer syntax. So basically, this is for methods that return something that is called a dependent value. So a dependent T basically has a dependee. Where is it? Like here. This is like there's some node is dependent on. So basically, this means it will only give you a value once this node has been fully analyzed. And this is used for tracking in the scheduler. So in semantic, we have all those binding functions that basically, if you mix in those, like here, so we have an what's a good example? Let's go to ternary exp. All right, as you can see here, so we're starting up the node. Then we're analyzing the first child, and it will automatically suspend the current node if the first child is not finished with analysis. Otherwise, we will continue. And here you can also see why it's important that it's reentrant. It could happen that you analyze the first child, which in turn triggers analysis of a third thing, and then it analyzes the first child again, and then it analyzes the current node again, stuff like that. So then we will convert the first child to something, and then we will analyze it again. Here we combine the types. And actually, type combination also can be dependent on facts that are only determined later. Right, because a common type can be just a common superclass, and the superclass can be generated, and so on. We also have interpret.d. This is just an AST interpreter. And we should also have here a CTFE interpret. This is a template that does a compilation to bytecode. So at some point we have a big switch statement, or is it? That interprets the yeah, you can see it was like 10 years ago, but trust me, there's a bytecode compiler. Okay, so we don't have that much time left, so I have also prepared some demos. Maybe those are a bit more interesting. So here we have a case that we've seen before where it's ambiguous, but the compiler selects something at random based on which queries you make. And what my frontend says here is that this declaration is invalid because otherwise this other lookup should have succeeded. Here is another one of those examples, and we get the same error message. Here we have the multiple modules, like A and B. And it's, okay, right, it's up there. And now this works across modules as well. It can also detect contradictions. What? I am. My bad. My backlight is very low. Fixed. All right, now I can see. It still says it. I'm still in this folder. Okay. Yeah, so here it also says it's invalid because here we say if it doesn't exist, introduce it, and it notices this. But then here's the other example that we've seen with the mix-in. It will also detect here that, well, you cannot introduce a foo because in this scope we've already looked up the foo and it is not this one. We have this overloading contradiction case that I've shown. Here it also says, well, the overload set was sealed up there, which needs to be done for overload resolution. In principle, we could store all the past overloads and then only error out if overload resolution would change, but that's a bit expensive, but it will be possible. Then there's also this case where DMD only declares X. My front end actually will declare both X and Y. And here's the more complex case where it did the same thing. I will also declare both. So this is an example of a Bear file that uses templates to compute a solution to the Queen's problem. I'm just showing this to show that my front end can handle templates. Of course, you don't want to do this. You actually want to use CTFE for this, and I can do this too. And so one thing you can see here is that I actually allow overloading local functions, which is disallowed in DMD, but it's completely safe here because, well, it seals the overload sets as soon as it's called anyway. And here it will actually output all the solutions using Pragma message. I have some more examples. So yesterday we had someone say that there is this rule that you put half of common Lisp into every C program. This is something that is usually in the other half. So we generate some codes in CTFE here, which then uses a continuation monad to translate those list comprehensions that it also parses. I'm aware I should be done soon. So we also have this case. This is something that DMD doesn't allow. So basically, it cannot see through this alias here, right? We call it with array int, so t should be deduced as int, but actually it cannot do anything here. What my frontend does is it just works. Then this is something that Steven mentioned on Sunday. So we have a struct that has a type member, and now we call it with s and some value. And here in the parameter list, it accesses a type member of the template parameter. With DMD, this will fail. With my front end, this works. And if another case of this, so you can see here we have this continuation template that creates a complicated delegate, and here we actually use it multiple times in an argument list, and it can run the code. It should have been able to run this anyway, and I tested it before. But we will skip this for now. I did try to fix something yesterday, and they might have screwed something up here. But here's a case that DMD cannot handle, so here we have a compose function. And in order to get B and C, we actually have to pass A through this template lambda, and then the result type has to be used to pass to this template lambda. So we get int to float to double, DMD just will error out here. Then here's just a case with CTF-feed to show that we can partially, that we can already interpret partially complete functions. So this foo here actually mixes in a call to bar, but because the call to foo is not on the path, this is valid. This also works with DMD, but DMD doesn't have a bytecode interpreter. Then there's this overloading case. So that on the forum there was a long discussion about adding implicit enum members. And then Walter said, well, the overloading rules, they would be too complicated with this. But actually, it turns out that with delegates, we can do a similar thing. So here we have two enums, one is A and B, one is B and C. Down here, we have A, B, and C. So basically, they somehow correspond to implicit enum members A, B, and C. So the first call matches the first thing because only E has an A. The second call matches both because both have a member B, and the third call only matches the third thing. And this actually works with DMD. What? Ah, yeah, my bad. It works with DMD if you leave this out. Yeah, so it's correct. You see there's one error, and this says this one is ambiguous. So DMD can already do this. This example is somewhat too heretical for my compiler frontend. At the moment, it will say all those calls are ambiguous. Then static for each. So my frontend had static for each first, and then I ported it to DMD. I can return sequences from functions. And back in the day, we actually used to have a comma operator. DMD cannot do this. My frontend can. So basically, here we have a sequence that is the second argument to a comma operator, and it will actually do the side effect here at the very end. All right, so let's get back to the presentation. I should have shown this to you before. So basically, there was some is type of in those examples. Don't use this type of. Race compiles is strictly superior. Jonathan yesterday showed an example with this type of that I'm quite sure is fine, but often it will not check for existence of context pointers, and then actually your template constraints will be too weak. I just don't implement rates in my front end. I don't want to promote this type of, just don't use this. We have shown the demo. I have not explored attribute inference. I also wanted to do this. Basically, my frontend doesn't infer attributes, and DMD doesn't yet do it for recursive functions, and it causes some issues. And there's some interesting questions related to attribute inference and introspection. And I do think we can do something interesting there. Then my frontend died with DMD 2.061 because I was no longer able to justify what I was doing to the compiler. Rainer Schütz fixed it, or made a patch to fix it in a later version, but it was never pulled. And I did file some reduced issues, but invariably it failed in other ways. All right, so I'm sorry for going a bit over time, but are there any questions?
Got Bruce up the back first.
It struck me that a lot of your abstractions, the things that you were using to build your front end, looked very multi-core friendly, right? Like your dealing with dependency graphs and continuations and schedulers and cyclic detection and so on and so on. And my question is if somebody were trying to do a multi-core version of the front end, would your structure be one that you'd recommend, or do you think that there's better ways to approach a multi-core front end?
I'm not sure. So basically, one risk here is that if you're running it on multiple cores, then multiple cores may want to access the same node at the same time at some point. And I don't know how much contention there would be. But in principle, it's interesting, and it wouldn't be that hard, I guess, or that much harder to make something that runs on multiple cores with this kind of structure, especially since we can just change what is in the mixins to completely change how the scheduling works. Another thing that I think the dependency tracking would be useful for is incremental semantic analysis, so that it only analyzes all the things that depend on the change that you made, so that you can get much faster iteration times.
Yeah, you said earlier you're not sure how it currently works in D. I want to take a stab at what I think is the actual way it does things. This could be wrong. If you find a contradiction with this, please let me know. So you have a scope, and first of all, you look at the top-level declarations in the scope. Those are taken for granted, can be in any order. Then it takes the static ifs, does them top to bottom, checks the conditions, recurses into their scopes, which have the same logic again. All the top-level declarations in that scope are directly available. And it just does the top to bottom, and then static assets are done separately afterwards. At least that's my understanding at the moment.
Yeah, that sounds relatively plausible, though I think it is incomplete. I think there is some logic also in DMD related to checking which declarations could be introduced by something. But okay. Yeah, I've never looked that deeply into it. I've just tested it.
It looks like we got time for one more question. So you know the rules, make it a good one.
There was a question in the presentation on the stream. Do you think that a stack of do it later can help you, or do you assume the limits?
What do it later?
I don't know. This is what it says, literally.
A stack of do it later.
I guess do it later tasks or something.
Yeah, well, I mean, the scheduler keeps track of all the nodes that are suspended. So yes, that is part of the scheduler. It's not a stack though, but it could be.
All right, well then I guess we're done. Thank you, Timon. All right, you guys know the rules. You got 10 minutes. Go enjoy them. Hello, hello, hello. It's time to stop talking and time to start sitting down. Nicholas is coming back up, which means he's done his yell out thing. See, normally I'm the loud Australian that yells out to the people downstairs, hey, we're going. But good thing we have a second loud Australian over here to do it today because my voice cannot handle it. Yeah, before we continue, we'll just get the logistics of internet questions correct, I think. So the deal is that wait until there's question times before you ask your questions, because a lot of time people type a question into chat and it only makes sense at that second of the talk, and it's 10 or 15 seconds out of sync anyway. So it's not very practical for us to have questions that are written before we open up the question time. Also, in terms of logistics, if there's 20 people having their hands up here, we're not going to get to the internet questions. The best way to make sure you have your question answered, be here in the crowd next year. DConf. But otherwise, we will answer the internet questions if it is practical. And please wait until it is questions time before you ask your questions. Cool. With that little bit of housekeeping out of the way, Marcelo, take it away.
Hey guys, good to be here again. Today I'm going to present regarding Scale D for real-world programming. This is a pretty brand topic. I hope I can get it in time, but let's do it fastly. But let's start up with what this talk is all about. That was a pretty hard concept to start doing. Basically, it's all about refactoring old code, underrated optimizations that I don't see many people working on when they're in a library writing. I also plan to reduce the output binary size. This year, I have tried participating in the 4MB Game Jam, and looks like I've used all my time from the Game Jam actually optimizing my engine to be able to participate on it. So it was a pretty bad experience on my side. And API design optimization. This is much more regarding when you build an API for your user, but you don't want the API get in the user wants. You want to make it as smooth as possible. So let's move up. So my background here is that I'm a game developer, author of Redub, which is a drop-in replacement for Dub with parallel programming, and Hyprim Engine, which focuses on being cross-platform in most of the time. I also maintain a lot of Objective-C bindings because no one had done that and put it on Dub, unfortunately. And I have also co-authored minimal D runtime for the WebAssembly and bare metal. It works right now even on Windows, if I recall correctly. And also, I specialize in rendering and porting. But before we can refactor, we need to identify how can we improve the state of our code. Basically, the dash profile GC is a flag that I don't see many people using. It has even some hidden benefits by using it, which I'll show here today. Other way to profile your applications by using gc.stats and gc.profilestats. You can get a lot of useful information in real time. And of course, you should always test your code in weaker devices. Sometimes the profile is not able to get some intrinsic keys when you're trying to run on them. But looking into the past, I have been looking some DConf talks. I have mostly been inspired by them rather than using them directly. From Roy, I have been using Atomics right now because I was just only using mutexes, and you see how crappy the code looked like. I have also adapted to use stack memory that Dennis presented. And even the data-oriented parser, I had something to add in my own code. So from Robert. There's a lot of good things you can take when you look on their presentation. I hope you enjoy their presentation later. So to begin profiling binary sizes, I have been using this ugly tool here from Twiggy. It's from Rust. Basically, it's how you profile WebAssembly binaries. I have been profiling my WebAssembly code generation basically because the complete runtime is not included, so I can use more time to focus on where I can actually do anything. On the left side, you can see the generated code with how many bytes they are taking. This is an optimized build for sizes, so we need to improve them by working on the profile binary instead of the debug one, because otherwise you won't get many improvements at all. And when you look at those functions, you'll see they have something in common. All of them is related to parsing. Yes, your parser is most possibly taking lots of your binary size. Maybe you don't know why that happens. Well, I show you right now. You can see this is a parser for the BM font interface. It looks okay-ish. It's kind of easy to read. It's not really complicated to understand how it works. But the optimizer can't do much about this. It won't be able to reduce the binary size when you have code looking like this. And this, in the end, when you do a parser, when it's time to stop doing it, when it works, you won't look this code anymore. But I finally find some reason to actually look at it again. The way I have been able to optimize this is by doing the most suspicious thing. It was by taking the address of every field and simply assigning them. With this, I reduced 13 kilobytes. And I think that if everyone started doing those kind of hacks, you'll be able to have a much smaller binary, which can be a really good improvement to the ecosystem when you're trying to develop your own library. Another way to reduce the binary size is that you must also be using a lot traitors all member. And I have even done this myself in a lot of places in my code. But this actually hides this AST when you're doing it. Yes, the optimizer does remove it, but the problem is that this only is removed when the optimizer is running, which means bigger compilation time. And when you look at it, you don't even need to use traits on members. As you can see, my enumerator here is a number. So just use the known information, just use numbers. It leads to much smaller binary, better compilation times. And of course, when I said optimizer removes this code, but that highly depends on what you're doing inside your for each function. So please be aware of it. Another thing that I've just said about using known information is that even if you don't want the type info is there. So maybe you should actually start using it. I had this function here which loaded assets in compilation time for forward the functions, and then I had other thing to process extra arguments. The problem is that it generates a lot of garbage functions when you're doing it. And the good thing about changing it to receive the type ID is that I was able to let the user also register their own types at runtime, which made a better API. And unfortunately, as I said, so type ID has some kind of bugs when you're working from the DLL bridge, so I can't really use it directly, but only in some places. There are other places which works. It's kind of random. This one here, it's all about forwarding your interface. It's pretty common pattern in programming to you create wrapper objects. And the problem is that when your wrapper is not doing much, maybe you could try just changing it to alias this. Much because this will lead to a linear type info from your class, leading to a much smaller binary size, I was able to remove almost 100 kilobytes by doing simply that. And there is a lot less code to maintain, which is a pretty big win for me. And also it leads to a better performance. And this is one kind of output from the profile GC. And this is pretty good because we can see where the code is being allocated. But what we don't only look at on the allocations, but instead on the bytes allocated part. Sometimes I have seen a lot of my code having much more bytes allocated than I really wanted it. And I didn't really know why. Then I started looking on this with a more precise view. And this is what I found. A lot of my enums were not typed. And the problem about not typing your enum is that even if you sort your structure, it will still use a lot of bytes because it's integer by default. And the ABI, since it exists the ABI, it can't be optimized, so you have to do it yourself. And in my experience, using Profile GC was a pretty good way to at least know where this is happening. So right now, just type all of your news. Another thing is that people coming from other languages might be using classes like completely unsorted with its fields. It's pretty common, like people coming from C#, Java, or JavaScript. This generates a problem that your classes is actually taking much more size than you actually needed. And the other thing is that maybe you should just start making your classes all final. As I say, because of ABI, the compiler can't optimize it without your saying it's a final class. And there is a lot of optimizations you're losing by not using it. For example, avoiding the vtable for function calls. And another thing about it is the most obvious one, it's finding leaks. Basically, there was some leaks that I didn't saw in my code, mainly because I have written a lot of code on it like 5 years ago, and I didn't knew a lot of techniques in D. And one of them was not using ranges for parsing the ini file, and using arrays without the .static array, and it was a pretty pathetic bug. Another one was that I was not returning the reference when it was found in the array. It took me almost no time to find this bug after using the profile GC, so it's kind of important to at least be aware that this tool exists. Another thing that we can do right here by using the profile GC and noticing how many bytes are allocated is that it actually can lead improvements to your performance. As in the data-oriented programming, we have always to try to fill it more in the cache line. So the bigger your structure, the less cache ideal it will be. For my simple JSON value, simulation of the standard JSON was taking like 56 bytes. And you can see how many profiles I've done there. After improving this code here, I've reduced it a lot by making it 16 bytes. I have basically reused the field of error for actually using a new type inside the JSON, so I could also share it. Another thing, I've removed string from the union because I was using the length field, which I didn't really need. Another thing is that the length is now part of the JSON value, which also encodes the the type of the JSON. So some parts are shared with the length, since the length is only used for the string. So that's basically a big win. And as you can see, it's 3 times faster to actually parse by doing this simple change. There was no algorithm change when I've done it. that also reduced the memory usage by 82% in the string dictionaries and 20% for the complete dictionary JSON. Another thing that this is much more of a thing I've noticed in my code that I didn't really expect, but this is a way I've been misled when I've done with static arrays, that I was trying to initialize statically the field to void. And it was kind of strange because for floating points, it actually initializes to 0, and it ends up initializing it twice instead of one time. It looks like a pretty bug to tackle later, because I don't know why this happened. And this misleads the library writer to think they are writing very good performance code while they're not actually doing. My recommendation would be to use opcall and void initialize yourself. As you can see, that's a pretty big difference in performance. And if your machine is very fast, chances are you're not catching this kind of thing. Another thing is that for reducing the allocation is to be constantly aware what's happening on your code. By using the real-time stats, you'll be able to do it. Profile GC, unfortunately, is not enough for this. But thankfully, you can have some kind of other options, like I'm showing here. You can just pass it by the command line, even if you want. Every D program should accept this flag, or even just setting globally, as I show here. And the thing about when I implemented this thing is that when I was using my WebAssembly runtime, it uses bump allocator. I know it's a pretty bad allocator when you're trying to do serious things, but this showed an interesting behavior that I was using reference counted strings for drawing text in my engine, and it actually started leading to fragmentation of the memory when I started concatenating some reference counted strings, because the B string is not destroyed before the C string, and this led to a big leak in the WebAssembly runtime. So the thing to fix it was kind of simple, and that Dennis showed his last talk, I think. No, it was 2 years ago. And the good thing about it is that it's pretty low overhead. And the good thing about bump allocator is that it's the fastest allocator you can get. And even then, stack memory was running in 33% of the CPU usage from the bump allocator comparison. So this string allocation, without initializing it, was pretty fast. It didn't fragment the memory. It was much easier to work with. It's the best tool for the fire and forget API, together with the linear temporary buffer. Now, talking about a little bit into scalability, I have added this year plugins to Redub. Basically, plugins are a way to extend the build behavior by simply passing some files which will get compiled with the dependency compilation run. And the good thing about it is that it unifies all behavior that you need for running. So, for example, you won't be needing to use RDMD, and all your paths should be the same. You don't need to special case anything inside your project definition file, which is a pretty big win. It's much better for maintaining your stuff. It's also used the same cache system from Redub, so it's easier to keep them working together. And this is a basic structure of a plugin. As you can see, you can define the pre-build, post-build, pre-generate, post-generate. It defines a bridge structure, which is shared with the internal one from Redub, and you can basically do anything. In this case, I'm just getting all the module names and outputting them for usage inside your low code, so you can actually iterate everything much easily. Beyond using plugins to it, another thing is that you need to accept that you don't know everything. And this happened a lot when I was doing my engine. Basically, there was some time when I needed unnamed dependencies. The reason I've done it was because the main was getting stripped off when I was building it inside a static library. I didn't knew there were other solutions for that. Of course, the solution is basically hacks, but you have to do it so your program will still be able to scale it much further. So don't do some tools that only solves a single problem. Usually, when the problem is like that small, like passing a dependency without its name, you make a tool for that, that's a really big problem for you in the future. You in the future, you hate you in the past. And the next thing is that when I've started doing this, I have also noticed this same behavior actually happened to every function you've tried to export inside your static library. So what I've done was basically generating functions from UDA to actually exporting them inside my main executable. And this actually polluted a lot the environment. This created a lot of garbage code, which also didn't really help into solving the problem in a scalable way. So the first lesson I've learned from that is that you need to exclude unused code as fast as possible. I've added Lua support from 2021, and unfortunately, it has been a really big problem for me until right now, which I basically excluded it, since Lua was basically entire function-based. For using your things, you may just use interfaces and functions that you need to export, which was adding a lot of overhead in my binary, and I wasn't even using it. And the problem is that after some time just using this way, I have started to not think in other possibilities, which limited me by a lot when trying to improve what I've done until now. And when also, another thing that you need to check is your multi-threading code anytime you learn anything, because chances are that you don't know what you're doing. And you can clearly see that I don't know what I was doing there. I see deadlocks. You can see this code here is basically using mutex for everything. There is a deadlock here happening, and I just run into a bug on that one when I tried running my engine inside a 5th PC. So it took me a lot of time to get this. But every time you try, you need to improve it somehow. And based on that, I've changed it to use Atomic. I hope I'm not doing it completely wrong. But at least it's running on all the PCs I'm trying it. I guess it became a lot better also to understand what's happening in this code. Only a single mutex is running, and I know that it's exiting there somewhere. And I don't think it's unsafe. I hope so. And continuing this is that you should never follow a single design style. Basically, for doing my worker API, I was using delegates everywhere. Where have I seen this from? Oh, JavaScript. Pretty bad language. Yes. And after some time, I've started changing it to actually use encapsulation on it with state machines, which actually done a big change. I hadn't the need to use mutexes anymore, since I could just check the current state and know if it's being touched by either other worker thread or even the main thread. And it was much easier to maintain and even to read what's happening there. And another thing that's pretty important when you're designing APIs is that relying on a single thing that you probably learned 10 years ago is not a good thing. As you can see here, I've tried using external functions, but I can't because I need DLL interface. P implementation is basically my failed test with Lua. Dependency injection makes a very verbose API, which I don't really like when trying my programs. The service locator was also not flexible enough when I was trying to build my renderer because I didn't want to make them depend on an interface which actually spawned the correct renderer in the runtime. And the solution was basically mixing both the service locator with dependency injection, so I could actually start my programs in some time. And this is an example of what a service locator is, for those who don't remember. Here I'm explicitly starting my service locator with a dependency injection for the file system interface. Comparing to the old solution, as you can see, I was basically defining a class that does nothing. It holds the function pointers. It creates an alias which will expand all of them into the global scope, and then it loads the function pointers. It's a lot. And even then, you also need to mark the functions which are exported with a special UDA, and this is pretty easy to get out of sync, so this is not a scalable solution. Getting better than that was simply using this dependency injection with the service locator stuff, because I would simply spawn a single interface and access its functions directly. This looks like a pretty bad conclusion for all this story, because all of this was basically caused by old code that I wasn't even using. And this is how deep in the shit you can get. Now, on the reflection thing, I have also coded a lot of networking this year, and I've never seen such good networking code being done. I'm almost proud of myself. It's amazing how good the API can be when you're using with D, because you need to share your API both in the client and the server. It's not that easy to get. It's not really useful in other languages. You can get it really wrong in runtime, and you don't know why this is happening. And the good thing is that all of this info can get generated in compilation time and be shared across both the server and the client. You'll get a nice API to use. You can also generate the type ID for the server to read as a special member, or even register delegates which are only run when you detect the correct information. And another thing which is pretty important is that you should, when trying to write networking code, you should always try to reserve as much as functionality as possible, because you mostly be implementing this again sometime, somewhere inside your client. So whenever you're able to share this kind of functionality, do it. Don't wait the shit goes down. Another thing is that you can get standardized serialization with not much code. Basically, you can also share, for example, arrays on the network by simply iterating all the members, checking its length and dumping it somehow and reading it back. It's pretty easy to do when you have like reflection to rely on. And this, of course, you're able to optimize the bandwidth costs, because you know your data, you know what's happening with it. You may be able to even compress it if you want. And as you can see, I'm basically choosing the type ID info based on how many types you actually rely. I don't think you'll be sharing 65,000 or more than that inside our network. you should definitely refactor your code and refer to this talk again. Reading it next, as I'm showing here, this is what autocode generation looks like. It's a good thing because you can simply generate functions which maps back to your original type, like there. For example, assign color, board state, or even action. I'm just doing a switch case on it. It also generated an internal delegate member, so you can also not use the polling API, but instead using the event-based one. And the good thing about it is that by using reflection, you will also be able to abstract away which protocol you depend on. The protocol for this one is actually using TCP and WebSockets together. It was kind of strange to make them work in the same way, but by using reflection, you'll mostly be able to. So my conclusion here is that when you mix different techniques, this will actually reduce a lot the complexity. I've shown this in the service allocator with the dependency injection. This will reduce a lot of workarounds. You won't need to generate a lot of stuff with reflection. Your code will run much faster. Your binary will be much faster. You can escape from refactor. From the beginning of my engine, I have already done like 16 refactors, if I recall correctly. Every time I needed to add some tool was basically that. Even though you can structure your code to make it as scalable as possible, trying to deal with so many devices and performance requirements, we'll always need to keep looking into it. It's not as simple as it looks. And when you don't understand your own code, it's time to refactor. That happened to me when I looked into my own threading code. It was pretty bad, as you can see. But at least by not understanding what was happening, I was able to improve its performance by 2 times. And also, whenever you don't know anything to improve your code, just do some kind of made-up challenges. This 4MB game jam was a pretty interesting experience to me, because I've never even thought about optimizing binary sizes, and I was pretty impressed by its results in both compilation time and actual running. The binary inside the WebAssembly done a lot of difference, especially since you can also simulate slow connections, and it reduced slow connections by 30% loading time, which is a pretty big win for me. And that's it.
All right, you know the deal. Raise your hand if you got a question. There we go.
Do you find in the sort of code you're writing that you are ending up kind of using a subset of D? Like you're not, like people who, like a lot of games devs in C++ will effectively write what they might call even C+, you know, like it's just a few things in C++ above C. Do you find you're in a similar situation with D?
I don't really find myself in a similar situation because, as you can see on the other extreme, you see a team on code like completely different of mine. But anytime you try to build a tool, you need to first think about what you actually need to do, because sometimes using the C+ is a great solution. You don't need to use the entire C++ to actually solve the problem. And when you start piling up a lot of features that the language allows, the thing is that it may get out of hand quite quickly. And why that happens? Basically, the same thing, you create a sub-language by using mixin inside D, for example. The code style of some people is like putting a lot of UDAs and doing some kind of stuff. I think Weka has done a lot of that. It's kind of hard to define a standard where you have such a general branding language like D. So the thing that this talk shows is that maybe you should just try doing what works for you, and be aware of what you're doing. You need to be ready to rebuild what you've done when you learn something, or else you can get in the abyss without knowing what to do next.
I have a question. Given that you care a lot about class instance sizes and memory layouts, why are you using classes instead of structs for these?
On this example, I didn't show, but actually I was using abstract classes because I've needed casting these classes to a class that work in the DLL API, so the user could actually put something or even use the class itself, because this was inside the main executable, so the user didn't have access to the class itself.
Okay.
Come on, more questions. No one? Check the internet and they don't have questions either. Surely somebody must have a good question. Just one more to wrap it up. There we go.
I see you've ported your engine to other platforms. Was type info a big offender in terms of binary size?
The thing about type info is that, unfortunately, you can't get rid of it unless you like to use programma LDC underscore no underscore type info. And the bad thing is that DMD starts to be cumbersome to use. You'll start to get a lot of things out of it. And actually, even myself, I'm not using DMD as much as before, mostly because I have my minimal D runtime to run on web, and because of that, LDC is actually building a lot faster than DMD with the full runtime. So the type info, I don't know how to escape more from it. I have also discovered that templates generate it, and even with the LDC hack, you can't get rid of it. The problem is that when you have this type info binary, you're just accumulating a lot of binary size, even if you don't want it.
Your DMD, no, your D runtime and Phobos in Wasm, which version is that? Is it up to date with the newest?
I have always tried to stick with the latest version of them, mostly because I'm pretty used to had some kind of compiler bugs, especially when I was beginning. I've done some kind of template abusing or even reflection abusing like Timon done. And every time I've updated, usually I got a better experience until there was, I think, some breakage from Phobos, mainly because of those attributes thing. I think I've got one of them. I didn't really like the experience of that, but I have always been trying to update it, or else I won't be able to update my minimal D runtime to the current state of it. For example, I know that now that the hooks are almost finished, I will need to port what have been done. So I prefer doing incremental work rather than complete from zero.
All right, I think that about wraps it up. So thank you. All right, now it's that time in 20 or so minutes that Attila loves. He gets to sit up on stage and take questions along with, where's Walter? Oh, he's around. But yeah, in 20 minutes time, we're giving them the third degree again. So get your voices ready. All right, are we all upstairs? Well, if you're not, too bad, because it's questions time. No excitement? Come on, questions time. Woo! I like your enthusiasm, sir. Keep that up for the week. All right, we all know the deal. The crowd will throw out questions. Even the internet will throw out questions. I've got my little thing here, so I'm keeping an active track on the internet questions at this point in time. Who's got a good first question? I'm going to take that as a hands up if you do that again. Come on, who's got a good first question? We've got 60 minutes, so come on. Here we go.
So Phobos 3 is going to be all exceptions, GC, super convenient, lovely. Is that kind of what you expect the nature of most D code to be? It's this like GC exceptions, that sort of style.
What makes you say it's going to be like that?
Well, I thought it was in talk, but
oh, not necessarily. No, I want to make it so that people choose how they allocate instead of the library choosing it for them. Like Walter did a bunch of work with things like an SED path instead of allocating and returning, to just return a rage instead. So that's going to be preferred.
Okay. Well, either my memory fails me or there's a conversation to be had with somebody about what was supposed to be in Phobos V3.
Well, Adam is splitting it up into more than one library. Like there's Phobos 3 and then there's based. And that's because there are distinctly different groups of people with distinctly different wants in what a standard library should be. So it kind of makes sense to have two libraries like that. So, yeah.
I think there'll be helpers that allocate that will just make it easier to use, but won't force people to allocate in the GC heap.
Well, in the current Phobos, I found a way to avoid doing allocation at all in some of the standard library functions, like an STD path. I found a way to concatenate paths without doing any allocations at all. And of course, that won't work everywhere, but where we can make things like that work, the problem just kind of goes away. Also, if a library routine needs to allocate space and then for temporary use, it can always use malloc free and the user will never know, and it won't be a problem. The only time allocation is an issue is when it's trying to return something that's been allocated.
Very lively crowd here today. Here we go. Steve's got a question.
So additions is coming up.
Yes.
And we know that auto decoding is going in there or coming out for that.
No.
No.
Auto decoding is only in the Phobos library. It's not going to be gated by editions. Editions are for compiler features, not library features.
So what is the first set of features that you imagine are going to be part of editions?
All the things that have deprecation on them.
Probably a few more. I think the obvious candidate is safe by default, but that doesn't mean that's the only thing we're going to do. Walter was just asking for me to give him a list of candidates, which is obviously something we're going to discuss and come to a conclusion over what's going to go in. But the auto-decoding thing goes away with Phobos v3.
Yeah, auto-decoding is not a compiler feature.
Going back one to what you said about malloc-free for internal allocations in data structures that don't return memory to the user. Is that just a way to honor NoGC, which would be kind of weird considering we have that in talk, or is it a matter of are we admitting that even the new garbage collector is not going to be as fast as glibc's memory allocator?
I think that'll depend on the implementation, but again, the allocation should probably happen on the user side. So again, with the ESD path example, If the user wants to allocate as soon as they get that range back, they dot array it, and there you go. But it's up to them, because maybe they don't want to do that. They want to sync it into some other algorithm, and then maybe some other algorithm, and only allocate after that. So.
Yeah, no, sorry, I agree with that, and I think that's a good idea. What I mean is more like if there's a function that internally needs to allocate, like why would it do it with malloc-free instead of new?
Again, maybe Node.js, but that would have to depend on the function. I can't answer that in the abstract.
I have sort of talked with Adam about this, but I'd prefer to have the user specify how, in some way or other, how they want things allocated if it absolutely has to be allocated in it. And so the user decides how the allocation is done, not the library function.
Which can default to the GC just for simplicity.
So if the output of a library function is a range, then the user can just take the output range and go dot join or dot array to allocate it that way. And that way the Phobos itself does not have to decide how to allocate it.
All right, we've got an internet question from Serg here. Zig has recently started working on their own back end as well, and they made an Arch64 pull request, had it merged. Walter, are you aware of their work or other language work related in-house to Arch64 implementation?
I'm aware of Zig. I don't really follow it, so I don't really know what they're up to. I do know they have a great marketing arm.
All my C programmer friends are into Zig at the moment.
Yeah, so on Hacker News, there's regular articles about Zig, and I respond to them with how the same idea is done in D, and some people like the comparison, and some people don't. But that's the way it goes, because every time there's an article about D up there, somebody comes up with a Rust example or a Zig example. It's, you know, it's all fair game if you're going to post on a public forum.
So in my custom range API, I have added a function which I call pre-allocate or even reserve. I was missing this inside Phobos, and I think it could be a great addition, especially if you want to use stack memory. You can track better if it fits or not the allocation, or even it can be used to improve the performance when you're trying to use the GC.
There's experimental allocators, which I have moved to non-experimental because I was waiting to hear from Paul Backus and the work he was doing, but it's still in there now. It's just under experimental.
Well, certainly stack allocation is the fastest allocation, but of course, if you need more space than you stack allocated, you've got a problem.
Well, you can have a fallback.
Yeah.
Walter, so in 2017, there was this Ask Us Anything, and you also participated, and it was also Scott Mayers there. And at some point, someone asked the question, and you said that memory safety is going to kill C. And now to put things up, I mean, some years have passed, 8 years, and during that time, like Rust had this, you know, enormous wave that it's been riding. And recently, reports have started across companies that, you know, people tried it and some have started to kind of push back on it. So maybe this could be interpreted as a sign that maybe memory safety is not something that is very important in many cases. So I'm curious if you kind of revisited that thought, or do you still think that memory safety is going to kill C? And also for Attila, like, what is your take on this?
I think memory safety, unsafety is killing C. And look at the adoption of Rust. And Rust is making inroads into system software and replacing C, and that's because of the memory safety problem. I've proposed changes or enhancements to C that did array overflow checking or array bounds checking. Array overflows are like the #1 cause of memory corruption in C code, and yet the C community still hasn't adopted this, and I don't understand why not. But C++ also has array bounds overflow problems, despite having Vector having a way to do array bounds checking. But memory safe languages like Rust, D is almost completely memory safe. It neatly solves the array bounds problem. I think people are just going to get tired of the memory, the array bounds overflows bugs and the memory corruption bugs. And I don't really understand why C and C++ don't do memory safety. You don't have, it doesn't have to be perfect memory safety, but when you can easily pick off the #1 problem, which is array out of bounds indices, why not? What are people waiting for? You don't have to switch languages in C to avoid that problem. C can be fixed, so it solves that problem. So I'm rambling here a bit. I just don't get it.
Well, like Walter said, I think that the existence of Rust and its adoption shows that memory safety is important. Otherwise, nobody would care. Nobody wants to have to deal with the power checker and annotate things if they didn't care about memory safety.
And there is a government initiative to be more demanding about using memory safety. And, you know, if you're a hobbyist or writing small programs, memory safety in C is not really a problem because the programs are small enough that you can understand them. But when you get into very large programs, I just think it's too costly to try to squeeze all the memory safety problems out of C code. It's too hard to do a manual review and discover all the memory safety issues. You need mechanical help for that, the larger the program is. There are solutions. Like I said, I've proposed a simple solution to C to solve that problem, and I'm amazed at the lack of interest. Instead, I see C add all these weird features like Unicode identifiers that need normalization, which requires a lot of code to implement. Why is that adopted into C and not adding a simple extension to do array bounds and checking? I don't understand it. But of course, that's why I'm working with D, is because you know, I disagree with the direction C is going with their enhancements and memory safety.
I don't think they see it as a problem. As somebody mentioned in a talk in CPPCon 2016, C programmers usually write the program and then the real work starts, which is debugging. So
yeah,
that's just how they used to working. Why would they fix it?
Well, I've programmed in C for a long time, and array overflows are the worst problems to try to track down. I did not like spending literally days, all day, trying to find a memory corruption bug. And after enough years of that, I was done with that. I didn't want to deal with it anymore. I wanted a language that would not have memory safety problems. And, you know, we have that in D.
There's a memory corruption bug I never found once. I fixed it by having a global array called only God knows why I need this here. And then, of course, the code changed and it started crashing again, so I kept bumping the number up.
Yeah. I mean, D is not 100% memory safe programming language. But it's so close that how many of you have experienced memory corruption in a D program? Okay. why did you have memory corruption in a D program, if I may ask?
Because I wrote code that looked like C.
Serves you right then.
So you were using pointers instead of arrays? Oh, well, you deserve
Same.
what you...
Because I wrote a new garbage collector.
Well, the garbage collector being broken is not the fault of the programmer. So yeah, if D and @safe code does not allow pointer indexing. So if you're using pointer indexing and you're doing it in unsafe code, you better know what you're doing and be careful with it. But if you're using arrays, you should not be having memory corruption problems.
Import C, doesn't it support this range check? I think there was some, you have some new syntax with a bracket and a colon and a bracket. Import C,
No, that's not an import C. That was in the proposal I made to this community to how to add an enhancement to have basically D slices.
Yeah.
Okay, and once you have D slices, you can do array bounds checking, and that's all it is. It's a simple enhancement. We all know it works. Okay, it's been around in D since the very beginning, and it's been an extremely successful language feature for D.
I actually agree. I think one of the best thing with D is actually just arrays.
Yeah, C++ is based around the pointer paradigm. The iterators are pointers, or it's an abstraction of a pointer. D, it's all centered around arrays, and the ranges are all centered around the concept of an array, not the concept of a pointer, and that's where the memory safety comes in.
So one way I've seen memory corruption in D is because somebody used a malloc-backed array and borrowed out like a reference to one of the elements. So is that something that should be supported in safe code in the future, or what's your thoughts about this?
You can get memory corruption with malloc by when you take your number of elements times the size of elements, and you wind up with a wraparound overflow, you can get memory corruption. But I'm not sure what were you doing with the data return from malloc?
Well, I mean, what you can do is like have a struct that basically represents an array that is in the background allocated with malloc. This can be made safe as long as you never return any references to the array elements from any functions. Like you cannot index this by ref, for example. But usually people want to do that. And then it becomes no longer safe because you can borrow out by ref some element of the array, and then overwrite the array with some different array, and it will in the destructor call free, and then you get the dangling pointer.
So are you? Yeah, if you mismanage your mallocs and frees, you can get memory corruption, and that's why malloc and free are supposed to be system code. The other problem you can get into with malloc is you get uninitialized data back, which can contain random pieces of memory in there. So if you want to be memory safe, you should be using calloc on it at a minimum. So I use malloc extensively, and what I've gone through is I've done a grep for all the mallocs and all the reallocs, and looking at the argument to them and making sure there's no wraparound overflows in passing the size to mallocs. So it's not done for you, but malloc is kind of a system allocation thing. The operator new does not have this issue.
Yeah,
but I think the way to get around that is to have that struct.
Yeah, let's take it offline, I guess.
Take a lambda and then operate on the elements, because that way you don't give references out. That's how I did it in AutoWrap.
All right, we have another internet question from Serg, but I'm going to modify it slightly. What is the most crucial thing to be implemented / fixed first in a short or middle term for D? And I guess outside of the memory safety issues that everybody's talking about.
I don't understand the question.
I didn't either.
Basically, what's number one on the hit list that that you think needs to be fixed in D for short to middle term gain?
Oh, I think additions is the number one thing. The compiler will still have to support the old code, but by eliminating obsolete features and stuff like that, we can simplify the specification to the language so that users will not be tempted to use deprecated features of the language, and we'll stick with the more modern version. So I think that's will help us move significantly forward in the quality of D by getting the additions in, because we'll finally be able to get rid of, the junk that's accumulated that has become obsolete and outdated in the language. It's just time to get rid of that stuff.
I think deciding on DIP 1000 one way or the other is the other thing I'd mention too, which is something I've been trying to work on recently by modifying it slightly. I just need to see if it works, and then if so, I would recommend turning it on, and if not, then probably abandoning it. But deciding one way or the other, not having it in limbo.
And I think an interesting follow-on from that, like we've talked about memory safety being the number one thing that'll kill C, and we've got solutions for that in Rust and D. What's the number two thing is what I'm interested in. What do you think is the second thing that will kill C?
C just looks so old-fashioned.
Yeah, well, I mean, D borrows its syntax, so you'll need to clarify there.
All right. My number one complaint about C is the macro language in it. The macro language is a hack layered on because of the limited memory space of the computer that the C compiler was designed for. So the macro preprocessor was a clever way with a minimal amount of computing effort to extend the power of C. Unfortunately, macros are completely unhygienic, and I used macros in C for probably 10 years before I realized that they were ruining my code, not enhancing it. And I went through and removed nearly all the macro usage from my code, including all the clever macros that I was so proud of. I decided I ripped them all out and replaced it with ordinary C code, and I was much happier with the results. The code looked better, it read better, I understood it better, and everyone I talk to agrees with me, and they say, but I don't write incomprehensible macro code. Every one of them, I get out some of their code and I go, you're writing incomprehensible macro soup. People try to do metaprogramming using C macros, and it's just an abomination. And the absolute worst case of this is wasn't actually in C, it was in MASM, the macro assembler for the PC, and a company had a 50K MASM program written by a programmer who'd left the company, and he'd invented his own language based on macros and had implemented this utility in his invented, undocumented, quirky language, and it had a bug in it, and management had given the job of finding that bug and fixing it to programmer after programmer, and they'd spend weeks on it and make no progress and could not find the bug. And then they gave it to a friend of mine who worked there, and this is how I came to know about this story. And he fixed the program in 2 hours and checked in new source code. And the manager was shocked and said, "How did you fix this in 2 hours when nobody else could make heads or tails of the code in there?" And he said, "Well, I made no attempt to understand his language. What I did was I assembled it, and then I ran it through the disassembler, which produced source code. I immediately found the bug, and then I checked in the disassembled code as the new source code for it."
I don't think anything will kill C. It's just too much of it. It's too much legacy. And even if something does, the C ABI will probably live forever. But I don't know, because I don't understand why people would choose to write C right now. Even not thinking about memory safety, it's just too much work. And I'm lazy. I don't get it.
I mean, C doesn't even allow forward references. Okay, I find myself writing C code because I was testing import C, and it wouldn't compile with a C compiler. And I go, "Why won't it compile with a C compiler?" "Oh, I'm doing forward references." I'd forgotten all about that. And import C, because it uses the D semantic code to do its semantic analysis, actually supports forward references in C. So I know it's possible. I know it works. I know it's very convenient. But why is C not doing forward references? It just, compared to modern languages, it just seems so primitive.
Yeah, a question about additions. Is there any set of things that are viewed as missteps or mistakes in D that you are known that can't be addressed via additions? Or is it always just a judgment call as to how far you want to move the language?
It's a judgment call.
Yeah, it's got to be one by one. But right now, I'm not aware of any that we couldn't fix. But I could be wrong.
So as you were saying, Rust has started to be used in a lot of places where C would previously be the only option. And then there are other languages in this space. There's Zig, Odin, Jai, etc. But Rust is perhaps the most different. And as that starts to take off, how does D's position for interop look? Because obviously it's easy to say, well, we rely on the lingua franca, which is the C ABI, but idiomatic Rust code doesn't look much like your average C. So, yeah, how?
I think that'd be a lot of work, and until then, use the C ABI, because that works with every other language too, because everybody speaks C.
The only practical answer is use the C native interface. It's the only thing that's going to work reliably.
All right, we have a question from the internet here, and it tends to be a can of worms with this question in my experience, from Cap'n Dev Plus. Will float ever be 0 by default?
No. I just had a long discussion last night about the NaN being the default value, and I have failed to make the case clear for why NaN is such a good idea. One of the issues is sometimes a compiler with warnings and all that will say, "Oh, you're using this, you declared this floating point variable and you didn't initialize it to a value because C doesn't do default initializations, and so it gives an error." And the junior programmer looks at that and goes, "I need an initial value for it to shut up the warning." So he doesn't actually look at what would be the correct initial value for it. He just initializes it to 0, and then the program compiles, and he walks away, never checking to see if 0 was the right value or not. So I know that scenario is fairly common. And the other problem is somebody looking at the code and sees it's explicitly initialized to 0, and then he thinks that's intentional. that it be initialized to 0. When actually it isn't, it was just inserted in there to shut the compiler up. So what I like to see with NaN, it's going to pretty much force the user to think about it a bit, what would be the correct initialization value for it, rather than just slapping in 0 just to shut up the compiler. And that's one reason for it. NaN also has the interesting property that your program will still run, but you'll get a NaN result. And sometimes NaN is exactly what you want. Like if you have a bunch of sensors, and if you have a grid of 100 by 100 sensors, there's always going to be broken sensors in your grid. And do you want the value produced by a broken sensor to be 0? Well, that could skew your whole result. But if you make it a NaN, then after you do your matrix operations and data analysis on it, in your output, you'll see NaNs where you don't know what the values are, but the parts that are not NaN, you'll know are the good parts of your data. So NaN is a very useful value. We also have NaNs for the characters, which is FF, which in Unicode actually is the invalid character, is FF. The NaN value for pointers is null, because if you try to use null pointer, you get a seg fault. Dennis suggested to me that the NaN value for an int should be int.min, and I think he has a great point with that. Maybe I should have made it int.min, but it's a little late to change it now. And for the same reason, it tries to get the user to think about what is the correct value for initialization, not just, because 0 can appear to work, but it can be wrong. And I want to encourage or try to bias people towards thinking about what is the correct initial value rather than just assuming it should be 0.
Also, equals 0 is a thing that people can do. It's 2 characters.
Yeah. If you don't like it, you can just go equals. Yeah. Another thing is, back from the C days, I remember spending 3 full days trying to figure out why my program behaved erratically, and it finally came down to I declared a variable and didn't initialize it, and it was initialized to some random value on the stack, which every time I would try to debug it, it would shift the stack, and so it would behave differently. It was really a miserable experience, and that was a motivating thing that is the reason why D has default initialization for all variables. And if you want it to be uninitialized, you have to proactively put in equals void. It's not going to happen by default.
It's really funny that you touched on this, because this is related to my question. You earlier said that when using malloc, it's actually unsafe because the memory that you return is uninitialized, so you have a pointer to uninitialized memory. But void initialization is safe, provided that you do it for non-pointer types in D. And you have argued for this in the past, and I think it's kind of a contradiction.
A little bit. The thing is, in order to use that void data, you have to cast it. And the cast then is when the will only be allowed in in code marked as system code. So that's kind of the out there. Is it winds up being in system code, and then it's your responsibility to get it right. Operator new doesn't have that problem. It will initialize the data for you.
So you still think that void initialization should be safe?
Yes, because if you want to do unsafe things with it, it's still, you're going to have to cast it, and then the cast will, oh, this is an unsafe cast, and so it has to be entrusted or system code.
The only other thing you can do is compare identity with some other pointer. There's nothing else you can do.
I don't really see where if I say int a equals void, how do I need to cast it? Maybe I'm misunderstanding something.
Okay, int a equals void, okay, means a is uninitialized and will contain garbage value. That can be a bug in your program, but it's not a memory safety bug. But a pointer being initialized to a random value is memory unsafe. And
okay.
so it depends on the type.
Okay, but with dip 1000, I can do int a equals void, and then do int pointer b equals address of a, and provided that b doesn't escape the function, now I have a pointer to uninitialized memory, and it's completely safe by today's standards.
But you're pointing to valid memory, and that's typed as an int. So it's not a memory safety issue.
So the problem when you have uninitialized stuff is that the optimizer is going to come after you and do things that you don't expect that looks impossible from the source code. So for instance, if you have an integer that is uninitialized and you use it as an index somewhere, well, no, the compiler is like, oh, there is the bound check, it's compared with undefined. I can like remove that because the whole thing is undefined, and now I'm accessing stuff that I should not be accessing, and the bound check is not there anymore. It's virtually impossible to guarantee safety when you have stuff that are undefined around.
Interesting.
All right. Well, there is a bit of confusion here. The safety is about memory safety. It's not about bug-free or random values. So if the random values cannot result in an invalid pointer access, it still passes the safety checks. Okay, it's only when somehow the random value or uninitialized value becomes a pointer, that's when the checks come in and prevents you from doing it. That's the way it's supposed to work. It's not impossible. There may be a way, I'm sure Timon can find a way in safe code to get an uninitialized value into a pointer, but all those methods of doing that are supposed to be blocked.
I think what he's saying is a pointer to nonsense is fine, a nonsense pointer is not.
I think it might be fair to say, as a generalization of Amory's point, that anything that the backend considers to be undefined behavior must be considered a memory safety hole.
Okay, we don't have quite the same notion of undefined behavior as C does.
Yeah, but the backend do.
Yeah, this is the thing. Like if you're using, which everybody, if you look at sort of production use cases, is dominated by use of LEC, which uses LLVM, and like it or not, you kind of have to. Now, it's not that LLVM is not configurable, and LEC does configure it to say, I don't know what they do with strict aliasing, for example. Maybe they turn it off. I don't know, but these backends have strong opinions about what is undefined behavior, and you only have so much control over them, and they really have been built around the C and C++ standards, and it's just very hard to escape that.
Yeah, you're quite correct, and I actually ran into that the other day. I was shifting a 1, the value 1 64 times, so it shifts off the end, and I expected the result to be 0. But the result was 1, because apparently if you have trying to shift more than 64 bits, it's undefined behavior, and so it did nothing. So that one caught me by surprise and caused a rather ugly bug in the code generator.
Okay, we have an internet question here, and I'm going to make no attempt to pronounce this handle, sorry, but it ends in Mo. So Mo has a question. And if you were to recreate D, what would you do different? I mean, now that you have like 25 years experience, I guess. So.
Oh, what a great question.
Well, let's just limit it to one or two good answers.
Well, I was just talking with people earlier today. I wouldn't have implemented the lazy attribute for function parameters. It turns out to be unnecessary because delegates are so much nicer. And I actually even tried to eliminate it at one point, but naturally, by trying to eliminate it, I found someone who had built their entire universe around using lazy. So this always seems to happen. No matter what features in there, there's somebody has set a store by it, and the only way we can deal with that really is additions. I think we did get it mostly right. There's some missed features in the language, like the compiler still supports complex and imaginary floating point types, which are completely obsolete now. Things like constructor syntax, I would pick a different constructor syntax today. I was talking about that earlier with Dennis. But mostly, I'm pretty satisfied. It's working out much better than I expected. One thing that I found when I list these features, usually it just has no impact. You know, all languages have their list of features, and people just kind of zone off when you hear the list of features. But D has one really nice aspect to it, and that is it simply looks nice on the screen. And I think it looks nicer than almost any other language. Other languages, to me, just do not look as pleasant to look at. And the other nice thing about D is, and I was talking to Bruce about this, is the language is plastic. It turns out that it's much easier to refactor D code than it is other languages, and the result of that, I discovered with my C code that my original data structures and algorithms remained intact from the very first time I picked an algorithm data structure through to the end. I never changed it. And I was wondering, why did I never change it? It was because it was too difficult to refactor the code. And I discovered when I wrote the warp C preprocessor in D that I changed the data structures and algorithms several times in order to get more performance. And it was easy to change the data structures and algorithms in D, and no other language I'd used was it easy to do that, and so it didn't happen. I was talking with Bruce about how Wicca managed to get such huge performance gains, like a factor of 60. And you don't get a factor of 60 improvement by improving the code generator. You get that by refactoring the code and trying new algorithms and trying new data structures. And if the language makes that easy, you're much more likely to do it than you are in a language that makes it difficult to refactor code. Both C++ and C are difficult languages to refactor your code with. And D is a very easy language to refactor your code. And so that's one of those things that you don't realize about the code until you try it. And along with the nice feature that D is just, it looks attractive on a slide. That's a big deal. And how many people have noticed that it looks good on the page? Yeah.
In our unbiased opinion.
I mean, do you really like all these colons and arrows and things like that in your code? No, it just doesn't look good. I think D has a familiar syntax to those who know C and C++, but it's a much more pleasant syntax to look at. I remember Andre Andrei Alexandrescu was doing a presentation on C++ code, and he threw up this slide with a bunch of C++ code to illustrate some clever thing. You know, Andrei's always got great slides, and I was looking at that and thinking, there's no way to format that code to make it look nice.
Wait for my talk tomorrow. There's some gnarly C++ code on the slide. And no, there is no way to format to make it look good. Or understandable for that reason, for that matter.
Yeah. A friend of mine, Bartosz Maluski, once, he got really enamored with Haskell. And he wrote this code in Haskell, and then he wrote the same code in C++. And in Haskell, it was like 3 lines of code, and in C++, it was like a solid screen full of code. And what he'd done was he highlighted the Haskell bits that were embedded in this massive punctuation in the C++ code. So with that, you could see the Haskell code in the C++ code, but it was surrounded by this forest of punctuation and various symbols, and you took one look at that and going, something is terribly wrong with C++. Now, I don't think D as simple as Haskell in its looks, but it's still much easier to look at.
I think in D, namespace is so easy, so don't even think about it.
Yeah. You think about it, though, when you try to go back and write some C++ code, then you go,
All right, we have another internet question here from Serg. Sounds like editions have quite a high priority. So what is the timeline on their release, and will they be aligned with the Phobos 3 release?
I'm going to defer that to Dennis, who's in charge of editions.
I was about to say the same thing.
Yeah, so the first priority this hackathon is the release process. But after that, the second priority is editions.
So let's say a generic soon.
Yeah. Soon, trademark.
Hopefully before the turn of the decade.
I have a question for Attila. You've written various DAP packages in the past, like AutoMem, DPP, Mirror, and Unit Threaded. And how do you reflect on those? Have they been superseded, like by import C, for example, or are they worthy of inclusion into Phobos, or just Unit Threaded replacing the default crappy unit test runner, for example? Do you have any plans like that?
It depends on which one of those, because, for instance, AutoMem depends on what I was mentioning about allocators before, because if we get that in, I think that should be part of the standard library. I don't think anybody should be allocating memory directly themselves. It should be using containers like a vector, etc., and smart pointers. So that would be a candidate. With respect to import C and DPP, for the most part, import C is a lot better. It's a lot easier to use. It takes less time. However, there are some workarounds that one can use with DPP that one can't with import C yet, because I have not yet convinced Walter to let me use code syntax and include the C header, because that's what I actually want. Because that way I have string mixins and templates to do workarounds for APIs that require them, which in my experience is all of them, because they're just things that won't work. Even if you do have macro support, it still won't work. And I've done this enough times now to know that I need the workaround. So that, I would say, is superseded by import C, but not completely right now. It would be if we had D syntax with it. And then the other ones, it just depends. Unit Threaded at one point, there was an attempt to put it into D runtime on Phobos, I can't remember. And then it got voted down. I also don't remember why, but it's a good question. Maybe what we should do instead, which is something I've considered, is making the default test runner a lot better than it is, because Unit Threaded is a big dependency, so that is a problem too. But that doesn't mean we need to settle for what we have there right now, because it's not that great.
All right, we have another Sorry, we have another internet question from Serg. This is the hot topic of AI. So some open source projects, for example, require people to disclose them in pull requests or forbid them entirely. So what would you think about usage of AI in pull requests here? And do you use them outside of the image generation shown previously?
I mean, I use it at work all the time. It's not particularly good. It's like having a really fast, bad programmer at your disposal. I get stuck in loops sometimes, and then you give up, because humans at least would try something else. As far as pull requests, we care as long as the code does what it's supposed to and it's good. I don't know.
Well, I've used AI a couple times to generate code just to see what it looked like. And what I find it useful for is when I can't understand the documentation on an API. And so I ask ChatGPT to generate a utility that uses this API, and then I look at that and go, oh, that's how I use the API. And so, yeah.
Another thing I find that good for it is to ask it how to solve a problem, and then it gives me a really stupid answer. And I go, no, but hang on. And then it makes me think of something else. It's like, definitely not that, but. And so it's good for inspiration by telling you what you definitely should not be doing.
That just makes it sound like a villain from an 80s cartoon.
I mean, the biggest problem I have with AI-generated code right now is even when it works, it has no good taste. It just doesn't look good. It doesn't seem to know the idioms that well. And if you tell it to do it, it still doesn't.
Now, my biggest problem with the AI is I keep trying to get it to generate D-Man cartoons. And it keeps coming up with something that looks like Spider-Man with a D on their chest instead of an S. Which is, you know, I know Dennis helped me with the prompting, and even he couldn't really get good D-Man out of the AI thing. So I don't know. I need to work on my prompting skills, I guess.
Timon's talk, I think, uncovered something that a lot of us have experienced, where a lot of the time we write D and we can do great stuff with it and it works, and then not that infrequently, we'll try to mix some features together or try to push the boundaries and discover inconsistencies or a lot of bugs. And I'm curious if you guys, I think, you know, the malleability or how plastic the language is makes it easy to mix things that weren't intended to be mixed. And so I'm curious what you think about, you know, the trade-offs that come from the design versus the implementation, or, you know, is this always going to be the state where, you know, if you start to push things too hard, you run into weird corner cases, or is there going to be a point where we resolve and everything, you know, seems like it works great?
Well, you know, Timon, of course, is excellent at finding problems with the language. And so his input is always very valuable on this because he finds things that nobody else does. The thing about the static if being path dependent is a significant problem. And one of the options is just eliminating static if from the language, but it's too darn valuable to eliminate. Another option is putting a great deal of effort into building a resolver that would find all these paths through resolving the order in which you're doing the static ifs. Unfortunately, I think that would require a lot of memory and a lot of compute time. And so I was looking at his slides thinking, oh, I know how to solve that problem. And I thought, oh, but wait, what if this was also done? It would still fail. When you combine these static ifs with if something compiles and with mix-ins of generated strings, you reach a point where I don't really know that there's a way to resolve these issues. And so I was thinking, maybe the correct solution is to simply document the order in which the compiler resolved these things. And then, because it's too valuable a feature to give up to do those things, but there's that, as Timon correctly points out, there's this mess you can get into if you're not aware of the order of evaluation. So I think that maybe the path forward on that is simply documenting the order in which it evaluates things, and then it's kind of up to you to use as you see fit. Like another problem not mentioned in this slide is you have a struct with a bunch of fields, and then you have a static if the size of this struct is a certain size, then add a field to it. And you see where the problem is. Now you've changed the size of the struct. What are you going to do about that? And at some point, as a programmer, you should just not, you should be taken out and, kicked off the team or be a no hire or something if you try something like that.
So about that, there is something, obviously it doesn't solve all the problem, but there is something that solves a lot of those problems that is easy to implement, is when you resolve a symbol into some scope and you don't find anything. So for instance, like if traits compile X, tries to see if X exists, you put a poison in there. And if later you try to declare X,
that only works in simple cases. Because I did think about the poisoning thing, saying, oh, this variable was already checked to see if it existed. We said it didn't exist. Now you're declaring it, issue an error. Okay, well, it turns out that that's only works in trivial cases because you can have, if you have the traits compiles, you can have anything in there. And detecting if a particular symbol is poisoned or not, and is, I think, in general, an insoluble problem. And so it only works in what you've done is just simply push the boundaries out a little, and then you run into the same problem again, but with a much more complicated aspect to it.
As you mentioned, like the proper solution for that kind of thing is probably untractable computationally. I mean, it's not like it's not possible, but you would have an algorithm with a high complexity and compile time that explodes. But you can still have like mitigation for the common cases.
But with respect to the original question, I think one of the important things here is to say no to new features because they might be combined in novel ways because programmers write adaptive things.
I kind of think we're just stuck with the problem. We should document it and, be modest in use of features. Like, don't use macros in C to generate your own metaprogramming language using macros, because all that leads to is to hell when you do things like that. And yes, the C macro language is completely specified, but you can still create a living hell with it, and why do that? I once heard long ago that Lisp is a great language because it has a very simple core language, and then you built on top of that by using macros. And somebody once asked the question is, why are there no long-lived Lisp programs? Why do people create a Lisp program and eventually translate it to another language? And I thought about that, and I thought, my suspicion is, again, that each Lisp programmer invents their own version of the Lisp macros, and nobody else understands the language they invented on top of Lisp, and nobody wants to learn that kludgy, special purpose, undocumented language, and that leads them to just scrap the thing and rewrite it in another language.
Yeah, there's decades-old Emacs Lisp code.
Yeah.
And there's a lot of macros there too.
All right, we're starting to run short on time, so we're going to keep it to 2 more questions from the internet here. One of them sounds like a good one to end the question and answer session on. The other one is from the D Language Foundation. Yeah, I think that just means Mike Parker.
Yes.
So he's asking, when we get base D, will that be the opportunity to drop the better C switch?
When we get what now?
Ooh, the base D thing.
Base D.
I don't know. It sounds like it would, but you know, I don't think I can answer that in 10 seconds or less.
Well, I always thought that better C, we should get to a situation which better C is a no up, because if you don't use any of the features, then that's fine. So yes.
All right. Then we can leave that one for a forum discussion, I guess. The question that I'm thinking would be good to end it on is from Matthew here, just Matthew. I assume that's his entire name. If the foundation had an unlimited pot of cash purely to spend on promoting the D language, what would it be spent on?
What I found the best way to promote the D language is to write articles about what you're doing. So I strongly encourage everyone who did a presentation to take their presentation, it's already been developed and everything, add words to it, and make an article out of it. And not a very long article either, just a straightforward one, and then we just make them available to people. People enjoy reading articles about how to do things in language and stuff like that, and it gets them interested in the language. It's not pushing it on everyone. It's just have interesting articles about programming, and they happen to use D, and that works pretty good.
Given unlimited budget, I would say Super Bowl halftime ad.
Yeah, will we get
Super Bowl
K-Dot to
halftime
do a
ad.
performance for us, though?
Yeah. I mean, again, unlimited budget, so we can do whatever we want. I could do the performance.
Yeah, but you're not K-Dot, man. Sorry.
I know.
All right, well, I think that's about time then. So give it up for our overlords. All right, and that wraps up day 2 of this year's DConf. Was it a good one? Was this the best talk? Oh, really? All right. So, you know the deal. We need to be out of this venue before 6. It shuts down exactly at 6. So, you know, just please make a quick pack up. Do your usual dinner plans, work out where you're going, and then we have...
Beer